and not really a rule. Similarly, timing in South Africa works the same way. The timing is just a guideline. We generally ignore what's given. Okay, so I need to welcome everybody here this morning. I apologize for Guy Midgley, who is not feeling well this morning, and he just wants to rest a little bit before he comes in. He'll come in a bit later. Last night we had the opening ceremony, and we had about, I think, 8 speeches. So for the benefit of those that weren't there last night, we're going to do it all again this morning. No, I'm kidding. No, we had a great evening last night, and we had inputs from a variety of different organizations, from the University of Stellenbosch, from our government departments, from our co-hosts, the SCOPE program and NAM S&T, from WMO, South African Weather Service, National Disaster Management Center, all had remarks. You all will have received a pen drive, and on that is the ebook, and in that are all the messages from all the organizations. We've printed no programs, but we do have one stuck up outside. This morning, inevitably, our program has already gone awry for 2 reasons. One is that Desigan Naidu from the Presidential Climate Commission is in hospital with a kidney stone. So he won't be talking. And our second keynote speaker is on an aeroplane somewhere between Dubai and Cape Town. So we have a bit of extra time this morning, which is a good thing, because inevitably we're going to have to figure out how we're going to do this. And I've prepared this line. It goes like this. It goes, welcome to this extreme event. Get it? And it's extreme in the sense that we are trying something different with the flash talks. We've got a really tight program, really tight program, because there's so much information that we do want to share. So what we try to do with these flash talks, this is going to take real cooperation from you. But if you don't cooperate, what we've got is this instrument. Now, for those that don't know, this is called a snoek horn, and it is a traditional implement used in Cape Town by the fishing community, who would go fishing and catch fish, and then on a horse and cart would go around blowing this horn to tell you that there's fish to buy. Sounds like this, or something like that. If you go over by 1 second, no, I'm kidding. So this is the timekeeper. There's also a little clock here to tell you for the talks. That's really important that we stick to time as much as possible. Inevitably, we'll go late, I reckon. I just want to talk about the outcomes of this meeting. So this meeting is not only for fun. It is for fun, but also it is of real importance. Extreme events are a real thing, and the enthusiasm and the quantum of interest in this meeting is testimony to that. We're not starting at zero, and we're not looking to solve the problem of extreme events at this meeting. If you expect to come here and say we're going to walk out with a solution, sorry. Really, what this is about is to learn what we are doing about it, and to think about how to be better organized, and to think about what we need to be doing. And that's really the outcome. The outcome will result in a document which we will present to our respective official organizations, including the WMO, who have come to attend this meeting, and to our various government departments, and through NAM, S&T, and SCOPE, to other international areas, to kind of give an expression of what we think as a community we need to be doing, broadly speaking, and hopefully it will enter into a global process that way. We also are going to produce the special issue of the journal Environmental Development from this meeting as well. So we'll try and include the document that we produce out of this meeting as part of the editorial for that event, for that special issue. Okay. So I've spoken to you about the program this morning. Instead of Desigan, and in spite of Desigan, we are very privileged to have Tlu Ramaru from the Department of Fisheries, Forestry and Environment to address us this morning. Following that, we've got two keynotes. So the middle one, Suri's keynote, we're going to skip over. So that gives Bruce and Mary Jane a bit of extra time. So that's what we'll do this morning. And then the only other thing I think I need to say is that we've produced these, bought a whole lot of these and put them outside. And the reason is that it seems to be that there is a wave of something. We're not sure what it is. I think it's swine flu that's doing the rounds. A lot of people are sick. So if you feel that you would like to protect yourself and others, by all means, wear one of these. Okay, so I think that's everything I wanted to say. So in which case we're going to move into the program. And so, Clue, if you are ready, sir, I'm very happy to welcome you to the platform and really grateful that you have found the time in your incredibly busy schedule to be here and to give us some inputs from your perspective. Thank you.
No, thanks. Good morning, Neville. Good morning, ladies and gentlemen.
Pointer here and there's a way to advance your slides.
Let's see.
Hope that works.
Okay. Okay. Good morning. I think just to reiterate, it's always good to interact with such a type of people who are having so much knowledge and experience within this field. My name is Laura Amaru. I am from DFFE. We coordinate work on climate change adaptation. And we believe that the outcome from this engagement will help us as well in a number of processes that we are leading from the department, from the policy perspective, but also building some of the key programs that we intend to really roll out in the future. I just prepare a few slides on this. Let's see. Okay. My first slide just really reflects on some of the extreme events. I know you might be having so much data that we will definitely benefit from. But I've said last night that this conference is taking place at a time where we are experiencing most of these extreme events. And we can see that from 1900 to 2020, there are a number of extreme events that took place, both from drought and your extreme temperatures, floods, wildfires. And you can see the number of events for drought. You have 11, which of course ensure that the number of population that is also being affected. Cold wave, you have 2 events within that period with a total of 52 deaths. Okay. And for heat waves, 1 accounts, which accounted for roughly, I think it's 11 deaths. Flooding and discounting those that happen in recent time. We had something like 6 with 233 riverine floods of 19 with 822 deaths there, and fires, you have your forest fires, 2 with 30 deaths, and of course a number of people affected, whether it's 1,600 on the forest fires to 509,000 to the floods, to all the way to even 20 affected on the heat wave. So these also demonstrate in terms of the rents, US dollars in the main, what the value of losses that has been experience. And I thought, let me put this slide just to kickstart discussion. And these will be some of the information going forward from the department perspective that would want to see it updated through your different system of data collection so that we can utilize it when we interact with the loss and damage work within the global space. And I've said yesterday that we are having this discussion today at the backdrop of an important piece of law that has been developed, being the climate change bill. And this bill has gone through a series of processes, and the main key objectives really are around two. One, to ensure that we can effectively as a country respond to climate change in a coherent and coordinated manner, building, of course, your low carbon climate resilient economy and society, and to ensure that we can respond in a very integrated approach. We have started this journey in 2018, and we are today in 2024, the sixth administration. We're just chatting about, I think it ended last night. But in essence, this has gone through the portfolio committee consultation. It has gone through the National Assembly. It has gone through the National Council of Provinces, and it is awaiting a signature to be assented into act. And it's going to be one of the key instruments that will then govern climate change in the country. We develop, of course, the National Climate Change Adaptation Strategy, which become a key reference instrument document that we will be driving in terms of advancing the implementation. So this piece of work that you are doing, Neville and colleagues, is going to be extremely crucial for us to see how can we, from the report, and how can we advance the implementation of the adaptation strategy. Well, it has quite a number of strategic objectives that I'm even going to get into key areas of interventions and the key layers of outcomes. And one such is going to be the issue of climate information, observation, network dissemination, and bringing all the key stakeholders together to advance this piece of work. And the bill will also be, the strategy will also be a legal document fully empowered by the bill, because the bill will require of us as government to have this adaptation strategy and review it on an interval of 5-year period. So that becomes now a legal requirement to have these planning instruments. We developed the framework on climate services, and I know a lot of you guys contributed into that piece of work, but I must confess that coordinating that piece of work and getting it off ground for implementation have been one of the mammoth tasks. And it's something that is still a bit elusive on how can we bring all key role players, both from the climate information producers and the users together, and ensure that we are able to have those products and services that can really support our response. It's one of the elusive chapter, if I can say, of us implementing fully this framework on climate services. In the main, this remain one of the key chapter within the National Climate Change Adaptation Strategy, and I think the key is to really have a coordinated climate service system in the country that will provide the product and services to key vulnerable sectors. And the big focus really is around, apart from revision, as I was chatting with learned colleagues from WMO, apart from the revision, the main thing is to develop a clear implementation plan to roll it out. These are some of the key vision that we have set for ourselves. One being around enabling a better management of the risks through the framework on climate services. And the mission there around mainstreaming and enhancing observation and monitoring of information to have those specific products and applications to ensure that we able to be user driven in addressing the value chain of this production, processing, and the application. And among other goals, one is to really develop science-based information and prediction as central, reduce the vulnerability of society and related hazard, advancing key national development goals. And the whole issue of mainstreaming the use of climate information is going to be very critical. Engagement between the providers and the users become the central for really implementing this framework and the utilization of the infrastructure. The whole issue of infrastructure is going to be very central for the country. These are the sectors that we looked into. As critical sectors, we have those that are covered into a global space, energy, health, water, disaster management, agriculture, foods, and biodiversity. But from South Africa, we have added human settlement and we have added the ocean and coast as some of the key sectors that we want this framework to look at. Then we initiated a process now on the loss and damage, which I think this piece of work will fit very well into this. For those who have been following the multilateral discourse, there has been at COP28, there was an establishment of the Loss and Damage Fund. And there are now ongoing work around the operationalization of the fund, setting the instruments, setting the modalities, and agreeing on the different financial mechanisms and instruments that would really support the loss and damage work. So as a country, we thought that this is an opportune time to initiate a process of developing a loss and damage program of work. We are mindful of the fact that we have different policies in disaster management, climate change, and many others that proportionally contributes towards addressing the loss and damage. But we need something that will be more coherent and bring all of us together to address the loss and damage. So we're working towards having a loss and damage dialogue in the country, sometimes around July. And we focusing on the main three objectives to say we would want to enhance the knowledge and understanding on the approaches to address loss and damage. We will want to look at the issue of access to support, including finance, technology, and capacity. We know there are different mechanisms internationally that are willing to support technical work on loss and damage. And we also want to strengthen coordination and synergies across stakeholders. Philanthropists are doing their work, civil societies are doing their work, government is doing their work. So how do we bring everyone together under the banner of loss and damage? So these are some of the expected outcomes. I'm not going to spend much time on really to build partnership, map the different economic and non-economic losses. So that's why it's going to be very important on your system of data collection and information management that will be able to have access to such information, issues of research and outlining the process in integrating loss and damage into a monitoring and evaluation system. Before he can blow his horn, we are having a series of workshops. And we started with the first one on the policy aspect on the 24th of April. And we just looking at the different policies that contribute to loss and damage. We are having the second one on the 5th of June, 2024. And our focus is going to be on information management systems, monitoring and evaluation. What type of system do exist? What type of data? Do we have a standard framework of collecting this data and so forth? And we will have the last one towards early July that will focus on financing for loss and damage. Then we will move to a dialogue and agree on a clear, coordinated implementation program that would really advance the loss and damage work in the country. So in a nutshell, Neville, I thought let me share this so that in the course of your discussions, we will also be looking on how the output of this conference can enhance some of these processes. Thank you very much.
Thank you. Thank you very much, Drew. So Drew, you've set a very important basis for the South African delegates here who really have got a bit of a context now of where the policy developments are in South Africa. And really this is where our work kind of ends up. Ultimately, it's this department of government who also, by the way, their agency is the South African Weather Service. So that's the sort of mothership for that, are really important role players, and very grateful that we've got that basis to keep in our minds going forward. I just wanted to I was reminded to say that there's really a very broad range of people. Drew was explaining about the National Framework for Climate Services, which reminds me to say that the way we've organized this conference is in sort of broad thematic areas. And this morning we're spending some time looking at the climate science. We also acknowledge, of course, that these are artificial, especially given the fact that we're looking to integrate this approach. Nevertheless, we've gone sort of antithetically against that principle and looking at things in kind of thematic areas. But they're not hard and fast, and you'll see that some talks might well straddle more than one of these themes. But you would have all noticed that your name tags have got a color. And that's important to note because we're going to use those colors to divide you into groups this afternoon. So just remember your color, and that's going to be important for later. Okay, so Clue, thank you for that. This leads us to our first official keynote, which is Mary Jane Bopape. And Mary Jane, as you all know, and if you can look in your books, you'll get her bio. That's your ebook. So Mary Jane is the CEO of, it's called Managing Director of SAON, the South African Environmental Observation Network, which I always get wrong. Thank you, Mary Jane.
Okay, thanks, Neville, and good morning, everybody. As Neville has mentioned, I'm with SAON, which is a business unit of the NRF, but I'll explain in the next slide what that is about. So in my talk today, I'm going to share some results from a study we conducted with a number of people. You can see there are a lot of authors there from many organizations that have contributed to the study. But I will also share some work that's being done by the NRF with funding from the Department of Science and Innovation. All right, I think first just to clarify, a lot of you know NRF as a granting organization. They give bursaries to postgraduate students, and we also give funding for research projects. But the NRF also hosts national facilities. We've got 5 national facilities, 2 are in astronomy, and we've got 1 that's in nuclear science, and we've got 2 that work within the environmental sciences, and SAON is one of these 2, and our vision is to provide world-class environmental platforms for a sustainable society. So just in terms of the topic of these 3 days, extreme weather, we've already had yesterday from the speeches that were given that extreme weather has been coming up in the global risk report. In this slide here, I'm just showing you that this year, extreme weather made it to the top list of the global risks that we will be dealing with in the next 10 years. And then if you look in the shorter term in the 2-year range, it came second. But you can see that it's actually been coming up. In 2020, the 2021 report, it was there. 2022, it was there. 2023, it was there. So it's really important that we deal with this area and hopefully get good funding. For South Africa, Chloe has already showed some of the extreme events that we've experienced. So we are not spared from these, and the weather, as well as the extremes that we experience, both of weather in terms of climate, are informed by types of weather systems that we are exposed to in South Africa. So our location in the subtropics means we get impacted by tropical systems, and we also get impacted by mid-latitude systems. As far as the subtropics are concerned, there is some influence. For example, if you've got a high pressure system that's dominating, you generally get clear skies, so no rainfall. But subtropical systems, the subtropical highs, when they reach, and you also have a system in the upper air, that can also result in some extreme event. So we've done a study where we asked the question, where in South Africa are we experiencing weather and climate-related disasters? And for these, there were obviously questions around where do we get data to tell us where are these extremes happening? So we decided to go with an international data set, international emergency database, MDAT, of CRED. They've got a really strict criteria in terms of what makes it onto their list of disasters. First, you have to have at least 10 people that die from that particular event, or you have to have 100 people that are affected, or you have to have a declaration of a state of emergency, or you have to have a call for international assistance. So what this means is that you will find that there are a lot of other events that have occurred in South Africa that made headlines, but that have not made it onto this list. So if you were to check the KLAM of the South African Weather Service, you'll most likely find that they've got a lot more events that have been recorded. So what we've done with that data set is we've just focused from 1981 up until 2022. And we've mapped, because they've got an Excel sheet basically that shows the location. And so we've mapped those against our 44 districts and 8 metros so that we are able to see on a map which part of the country are reporting the most. And then the next stage of the study, we looked at CHIPS data, which as far as I know is the highest resolution rainfall product we've got available. And just to compare the floods and storms with average rainfall. And then we looked at the ERA 5 reanalysis and the synoptic charts at the South African Weather Service to check the weather systems that were responsible for these events. So you can see there that basically similar to other countries, floods are really dominating in South Africa. So this is what Chloe has already showed, followed by storms. Storms would include thunderstorms and tropical cyclones are included in that. And then we've got 11 droughts as already shown. And then we've got some wildfires occurring. And then the other bar chart, the stacked chart, it shows you when we had these events were reported, and you can see in 2022 we actually had 8 flooding events. So that was a record in terms of the floods being reported in that year. All right, now if we were to ask which parts of the country are reporting the most disasters, and you can see eThekwini, they're really jumping out of the page. And I think that is what we've all really been experiencing, or when you watch the news, we really feel like there's something happening there in eThekwini. And you look at the rest of KZN, you can see that it is also reporting quite a lot of disasters. And if you look to what's in the West, I mean, you see there's not actually a whole lot happening, but you see Cape Town actually just jumps out as well when you look there in the West. Right now, when we split the top 4, so the floods being the one that gets reported the most, you can see eThekwini there with KZN in general really coming up. You look at Gauteng, you see Johannesburg Metro reporting the most events in the whole of the Gauteng province. And then when you look in the West, you can see again Cape Town is really coming up when you compare against the rest of the province or the rest of the western part of the country. And then when you look at the storms, eThekwini is again showing up. This time around, we've got Ekurhuleni in Gauteng province reporting the most. And then again, you can see Cape Town in the west again jumping out. With the droughts, you can see it's basically the rest, most of the eastern part of the country. But you see Gauteng there, which I assume is because of its urban nature, not quite having, it doesn't really compare with the rest of the eastern part when it comes to the number of droughts that are being reported. So now just moving on, so now this is just an average from CHIPS, as I mentioned. So the resolution of this data set is about 5 kilometers. So we're just asking, do we see Cape Town jumping out in the west? Do we see eThekwini municipality really jumping out when you look at the rainfall that is received? So this is just average rainfall. So this is average rainfall based on events where the rainfall received was greater than 20 millimeters, greater than 50 millimeters, greater than 100 millimeters, and you don't really see these metros really jumping out. Yes, the western parts we know is generally dry, which is why you don't really get a lot of events, but you can see that there's an element that speaks to where you get the most people or the most development, in that the urban areas or the metros kind of jump out when it comes to the number of events that are reported. So this one just counts the number of events with the thresholds that I showed, and then that I showed in the previous slide. And you can see again that you do have some areas where really heavy rainfall events are reported according to CHIPS. So basically a disclaimer, this is not actual ground observation. This is a satellite-based product, but that has been calibrated with ground observations. Then the next question we asked was, what are the weather systems that are responsible for most of these events? So as I mentioned, we're in the subtropics. We're impacted by systems coming from the north, from the tropics. We're impacted by systems coming from the south, from the mid-latitudes. And you can see the mid-latitude systems are really winning on this one. So the cutoff low systems, upper troughs. So they're both, I mean, I guess bad news and good news with this. I think the good news that we are seeing is that most of these disasters that we've seen are because of systems that we can forecast. Like a cutoff low system is not going to hit us by surprise. When it comes because of its big land scale, the models are really able to capture these. And generally, you'll see there'll be a media release coming from the South African Weather Service before it hits us. And then the tropical cyclones, South Africa, in terms of disasters, up until 2022, well, from then, there've only been 4 that were reported. So there was the Domoina, Imbua in 1984, there was Eileen, there was Ntando, and there was Eloise. So these are the ones that really impacted us. Idai made headlines, but it didn't really impact South Africa. And then we've got upper perturbations. With upper perturbations, these are a bit difficult. So only 4 of them were responsible for a disaster, because models don't really do well in terms of capturing these. And then the surface lows were kind of, we could just see that there was a low sitting there that didn't quite qualify as a coastal low. So I did this, this was done really manually, where we looked at synoptic weather charts, we looked at Era 5 reanalysis, we looked at cloud patterns. So we had to sit and look at each event with Professor Chikore and Innocent Mbokodo. So now, so that's that for that study. So now I'll just move on to share some of the initiatives we have that are going on. We are working with the Presidential Climate Commission as well as the African Climate Foundation. So it's us at the NRF Sion with the South African Weather Service, and we are working to produce a climate risk report. So the idea is to look at what we've got just in terms of the literature. What do we understand in terms of predictability? There's some observation analysis that is being led by SOS. So you can see in this map here that this is a typical map that SOS would produce, where we are looking at the trends, what's happening with the extremes, what's happening just with the mean in general. And then we are also going to be talking to impacts in water sector, agriculture, disaster sector. And the work is going to be published on the South African Risk and Vulnerability Atlas. So Sion is hosting the system. We know it started back in 2008, hosted by the CSIR, and in 2015 it was moved to Sion. And the big output, or at least the PCC's hope with this work, is that the big output that will be coming out of it is just a determination of what is the infrastructure that is needed in South Africa for us to be able to have proper climate services. I also just want to mention the South African Research Infrastructure Roadmap. So through the Department of Science and Innovation, South Africa is implementing this. And as far as I know, we are the only country in the African continent that has a research infrastructure roadmap. In 2013, there was a project funded by the Department of Science and Innovation and the European Commission to determine what medium to large research infrastructures are needed in South Africa. Initially, there were 17 that were identified, and then following some, further processes, 13 research infrastructures have been identified. For our type of work, basically the environment sector, there were 5 research infrastructures of the 13 that were determined. And the ones that you see in blue there are research infrastructures that we are hosting at Sion. So this roadmap was launched in 2016 at an international conference for research infrastructures, which was hosted here in Cape Town. And in 2017, there was funding now becoming available for this. So through these research infrastructures, we are putting up observations. Some of you may have heard of FTON. There are 6 sites that have been identified where we are going to be putting a dense observation network. There'll be at least 6 AWSs. We are putting flax towers. We are looking at what's happening with the vegetation. We are checking what's happening in terms of water quality, water amount. We also have the shallow marine and coastal research infrastructures. We are implementing 4 sentinel sites and a number of satellite sites. Again, we are going to be taking a lot of measurements there. We're interested in what's happening, sea surface temperatures, the quality of the water. And then we do collect profiles going down. And we also have the South African Polar Research Infrastructure. And just last month, we had the first set of overwinterers that went to the Marion Islands, who are going to be taking some observations of mammals. So that's continuing work that started at the University of Pretoria. And then up here, you are just seeing some of the sites that we have. So you can see we don't cover most of the country, but we do have sites that were identified very strategically. That will be able to inform the development of some products, calibrate satellite information, and then the development of models. Our data is open. We've got a catalog, so you can go onto our catalog, search for the variable that you are looking for, and you can be able to download the observations that we have. We also provide a platform for farmers, so anyone else who's got some products that they would like to be available to the rest of the community. So you can just go there. If you've got a data set that you'd like to share, you can just upload it onto our platform, and people will be able to download the data. We are the so UCT and Sion are the only ones in the continent that have got this core trust seal, and it means that we are trusted as a data repository. So if you've got data or you've got products, you've got results from your studies that you'd like to share, you can upload to make them visible. We're also doing a lot just in terms of science engagement. We've got courses that are accredited by the South African Council of Education on GIS, which can be relevant for the extremes. And we also have a course on biomes of South Africa that we provide to the educators, so that it really helps them with their curriculum. And we also have the graduate student network. So once a year, we've got a conference where we have postgraduate students meeting just to share the work that they are doing. So with this, I'm just showing you some examples of some of the equipment that we have. We've got an aircraft. Following the 2022 floods, we were asked to go and take images of the damage that occurred because of those floods. Right now, we've even loaded a LiDAR, At the moment, we just want to survey the rest of the coastal area of South Africa so that we've got a baseline of what it looks like. And then in the future, if the disasters do occur, then we can just go back to survey so that, against the baseline, we can see what damage has taken place. We've got sites where we are comparing what's happening with the impacts, for example, of different biomes. What happens if you've got a grassland versus a forest in terms of your water availability, in terms of carbon, and we're putting up a whole lot of flax towers. This example you see here is on the Cathedral Peak, one of the stations. We can't reach it. We need to rely on a private person to give us a helicopter. So in this room, I just want to mention Dr. William Bond, who was a chief scientist at SCION, who was one of the people that helped with building SCION to become what it is. So just to conclude, we've got environmental platforms. We are collecting data. Data is open if you wanted to use it to be able to understand what's happening with our mean climate, what's happening with the extremes. We've got an open data policy, and we've got a core trust seal certification. We are host of SARVA, as I mentioned, which is open for you to come and upload your information. So SARVA is not just there for SCION to share their information, but it's available for you as well to come and upload information. We also have what we call a research associateship at SCION. So that means you become affiliated with us. And when you publish papers, you can list us as your affiliation. And there is some funding that is associated with that. So you get some money for your publications where you're affiliated with us that you can use to support students or to travel or to buy laptops. And as mentioned, we are also happy to link up on science engagement. We are really big with supporting educators, school learners, and we also have a graduate student network. I think we've already announced the conference for this year. And the other thing I wanted to mention was that we do engage a lot internationally. For example, we are a founding member of the Global Ecosystem Research Infrastructure, GERI, and that allows us to really engage and collaborate with other research infrastructures globally.
Thank you. What I'll do is, we have enough time, is once we've got the inputs this morning, we'll see if we can take some time to field some discussion and questions if time allows it. In fact, we're ahead of schedule, mostly because Suri, who is now to speak, is on his way still. So we'll try and squeeze him in later in the program, but that gives us a bit more time to play with. So Mary Jane, thank you very much. Really, not only the work on the extreme events, but the broad context of the work that you guys are doing really fills a huge space and of great value to all of us. And we have to think about ways in which we can all engage properly with what is already established. So thank you very much. I'm sure there will be discussions about the definitions of extreme events and how this data was interpreted, but we'll try and get that for later. But thank you very much. So that brings us to jumping over Suri's slot to Bruce Hewitson, who is there. And Bruce, known to all of us here from South Africa, is the director of the Climate Systems Analysis Group at UCT, among many other accolades. In his bio on the stick, if you want to know more. Bruce, the floor is yours. Thank you very much.
Thank you. I'm not sure you want to read my bio. It's pretty boring. So I'm going to talk about an elephant in the room. And I'm going to talk about it in the sense of this is something we've made just about no progress on in the last 2 decades. Talk about it in the context of a global action, an initiative, a new push around that, in a way as an invitation to actually participate for the South African community, because the South African community has to deal with this elephant as well. It goes under a number of terms. I've talked about the robustness of communicable information. We talk about context, decisions, consequence, fitness or adequacy for purpose, transparency, accountability, and even ethics and values, which is actually really important. Hopefully this works. Yeah. So here's the formal problem statement. I can't read from this angle. So I want to get the words right on this. So the formal problem statement is the absence of consensus or general agreement on how to address the non-congruence between sources of climate information. Non-congruence meaning they don't overlap. Choose your source and you get a slightly different variant of the information. That presents a significant barrier to the use of climate information to inform decisions, because you have to have an accountability for making an action with consequence. And what are you predicating that on? What information are you using? So the colloquial version of that problem statement is, how robust is this information for informing decision, which will have substantial societal consequence? And the consequential version of this is, will you accept proportional responsibility for the societal consequences of your decision based on this information? In other words, will you put your own reputation on the line to act with the consequence on the information that you're choosing to use? And this is a problem. So it'd be nice to have a screen here. So if we want to balance the adaptation cost with risk exposure, so as you go into extremes, the adaptation cost skyrockets. If you want to do adaptation to extremes, that's a very expensive adaptation measure. And you want to balance that when using climate information to make decisions of societal consequence. So this is a tension-filled space that we're working in. And we need to think about seeing non-congruence being the lack of complete overlap between the different information sources. And what is robust for a decision maker? Now, robust, I'll come back to that term a bit later, but if you're a decision maker, you want to defend the action against the measure of risk, which is different from the formal uncertainty statements that a scientist may adopt. And how do you know if your climate data is robust enough to trigger the consequential adaptation option? So I'm going to give you 3 scenarios here. The first one, a city planner developing stormwater infrastructure for urban expansion. These are real scenarios. If you are planning on expanding your urban scope, now this is the development outside of a city, expanding the city, you're putting in water infrastructure, do you put in big pipes, standard pipes, smaller pipes? Do you put in pipes of 25-year lifetime or only 10-year lifetime? These have huge financial consequences. And if you choose an expensive solution, you're taking money away from poverty alleviation, other development avenues. So there's big societal consequence to it. And if you're going to predicate that on a statement about extreme events into the future, do you trust that information enough to take that consequential action? Second scenario, a resource manager deciding whether to invest heavily in large-scale preemptive development of groundwater. That has all sorts of consequences, both in terms of the infrastructural costs associated with it, the environmental disruption associated with it, what it does to the groundwater, whether it's deep groundwater or shallow groundwater, and so on. Again, you're making that decision against a presumed future climate. And you're trusting that the information on which you're making that decision is robust. Third scenario, a risk and resilience manager redesigning flood lines. And when redesigning the flood lines for some future projected change of extreme events, it's going to entail community relocation, which is a political minefield, let alone a social hardship to do that. So we have scenarios where climate information is leading to dramatic social consequences. And we have to ask the question, how robust is our information for making these decisions? And do we even have a way of measuring how robust it is? Especially for climate change, which is non-verifiable until the climate change has happened. So, dealing with this, we held an expert meeting last month in Brussels. We being the World Climate Research Programme's Regional Information for Society core project, which I happen to co-chair, which is why I'm talking about this. The Green Climate Fund, you all know about the Green Climate Fund, the biggest funder in the world. They disperse about $4 billion a year. Well, they try to. There are problems about that. And the Global Framework for Climate Services and the European Commission co-hosted this. And we had a meeting specifically on robustness of climate information for decisions. We had about 100 plus participants. This was by invitation only. We had a conversation-focused meeting. In the 3 days of the meeting, we had one keynote talk. That's all. We focused on this meeting being catalytic for new initiatives. This is not about just, here's what I'm doing and how wonderful we are. And we addressed 5 key communities: the donor agencies, the decision makers, the impacts researchers, the climate services, and the climate science. And the focus was on, we need to have a conversation about this elephant in the room. The one keynote happened to be from a South African, Colleen Fochel. If you've ever heard Colleen talk, she's very provocative. And we gave her the challenge of saying, will you be extra provocative? We want you to disturb people. She arrived and she dyed the front of her hair pink, which was delightful. And she spoke about used car dealerships. And of course, you know, all the sort of sensitivities about a used car dealership. And she related this to those who purvey climate information. And what does it mean? How do we need to think about this? She was very provocative and set the stage for very good conversations behind that. So the first thing we spoke about is that we live with a common language yet differentiated meanings. And we have that in the room today. We all come from different backgrounds. We use words, but we don't understand in the same way. And I pick up just first here, what is robust and what is fit for purpose? The scientists like the word fit for purpose because that means I can put a metric to it. I can measure it. I can report it in a more scientific way. Robustness is a little bit more nebulous. And immediately in the meeting, we had this tension. Some people didn't like robustness, and they tended to be the hardcore scientists. And other people really liked the word robustness because it was an intuitive sense of, yes, I can act on this. But we don't know how to measure robustness, but yet the stakeholder and decision makers tend to lean towards using that terminology. And then we also unpacked the fact that non-congruence, the non-overlap, has two codependent aspects to it. The one on which the meeting was initially predicated, but expanded to adopt the second one as well, is the conundrum that the different choices, the different sources of information don't overlap completely. Choose your source of information, you'll make one decision. Choose another source, you'll probably make a different decision. And that is an ethical problem. We also have the problem of the non-congruence between context and information. Typically, we have information created, generated, translated, and then delivered into a context with the presumption that it's going to be useful. So let's deal into this a little bit. Epistemic non-congruency. Now, it's interesting. Epistemic and non-congruency were words that actually many in the conference didn't know, which really shocked me. But then I like words, so maybe I shouldn't be. Epistemic simply is, how do you know what you know? It's the knowledge base, okay? How do we know something? So epistemic is, how do we know something about non-congruency, the non-overlap of the different data sources? And I want to point out here a figure from a colleague's paper, Alessandro Dossio. I'm losing it. A really interesting, whoopsie, go back. The left-hand column is the CMIP5 global models projection of rainfall or different attributes of rainfall. The second column is CMIP6, which is the later generation. Then we have Cortex, which is the regional climate downscaling. And we have Cortex Core, which is a subset of those models done to a much more rigorous framework. And you have all these different parameters. You have the seasonal average, precipitation intensity, number of rain days, maximum daily precipitation rate, and the number of consecutive dry days. And you can look across and you can see agreement and disagreement. So, for example, the maximum daily rainfall rate, the different sources agree. But the mean rainfall change, the seasonal rainfall change, don't agree, nor the number of consecutive dry days. So we have this problem where the models agree on the extremes, the different sources. If you looked only at extremes, your different sources would agree, but they don't agree on the seasonal average. Do you trust the extremes if they don't agree on the seasonal average? We have a problem here. And yet we blindly push ahead and saying, I'm doing extremes work, they all agree, so I'm going to trust the extremes message and act on the extremes message with societal consequence. Now, you may be right in doing so, but there's a fundamental issue here that's not being addressed. How do you know how robust this is? So we have an epistemic issue. How do you know something about it? You have a transparency issue. I spoke just 2 weeks ago to the lead scientist on the Earth system modeling work in the UK. And he said to me, but I'm transparent. All my work is published in my papers. And I had to point out to him, firstly, not all your work is published in the papers. And secondly, that's not being transparent. So we have a transparency issue at all community levels, not just that community. And then we have a community issue. The different silos of research do not, by and large, talk to each other. Even the modeling communities, the regional and global climate models, don't really engage. And we need to have a cross-community collaboration, a transdisciplinary collaboration, if we're going to address this elephant in the room. So the other non-congruency is context and information. Typically, we're used to going from the modeling work through to some sort of spatial scale, right down to the local scale. And we presume that we have value when we get to the end of the chain. Very seldom, unless you're doing a very intense, labor-intensive co-production process, do you start on the right-hand side and go to the left. So we have a non-congruency of context and information again. So let me take you back 15 years, 13 years, 14 years, to 2011. How much have we made progress on this issue? This is a slide I presented at the Open Science Conference in Denver in 2011. And I talked about there's supposedly this objective climate reality. We have a past and we have a number of possible futures. And we have the user community who has variable awareness of this. We have scientists trying to understand what the elephant's going to be doing, usually saying it's probably headed that way. And then we have the mitigation community saying, oh, I think we can keep it under 2 degrees with a bit of luck. We have the adaptation community saying, you should go over there, do this, do that. We have boundaries between these communities. And we have other communities, self-interest community, I'll wait until you start something first. We have the denial community, what elephant? We have the conspiracy community, it's only just a mouse, he's just trying to take advantage of me. We have the catastrophe community, it's the end of the world. I don't suppose we've got any journalists here today. We have the funding community. I'm not really interested unless you put it on my agenda. And this is particularly about the global north, global south dynamic. We have the best of intentions, but I'm not very self-aware community. I've never seen your elephant, but I can see what to do with it. Okay, this was in 2011. Has anything changed? And then we also have the global economic, the famine and war, the political instability paralysis, and the global epidemics and disease. I didn't know all these things were going to happen, but we said this in 2011. So we haven't made much progress. Hence, why we had this expert meeting in Brussels last month. So the key outcomes around this is the first step is we've established an international working group to try and oversee the collaboration and coordination of new initiatives and new conversations around this issue. And this will be running within the World Climate Research Program, but it's not exclusive to the World Climate Research Program. And we have the Green Climate Fund particularly on board, and we have a number of other donor agencies very much supporting this. We've got a core set of team members. I'm not going to go through all the details. We're building communications, identifying task groups that we need to put in place, frameworks for communication, and so on, and building exposure around this. What are we going to do? Who wants to do what about this? So we had a number of emergent topics coming out of the expert meeting. Now, interestingly, those bar graphs are not statistically significant. You can't say one's more important than the other. They're all within the noise range. But they're all ranked high. In other words, all the participants ranked all these issues really high that we need to address across the board, which is a problem because we haven't got any, where do we start? And so we have to deal with this issue of where do we start with all this? We asked them, what is your commitment to this? And we had very strong commitment. So 17 participants immediately stood up and said, I'll champion something. Put me on the top. I will take charge of this and I'll drive it forward, which was amazing. 65 expressed interested in participating in one or more of the meta themes. We had a whole bunch of extra topics suggested. 65 participants expressed intent to share the outcomes through their networks. And 36 participants volunteered to be on the interim working group to try and oversee this progress. We can't have an interim working group of 36 people. But this is just a demonstration of the level of commitment and passion of the partners, of the participants there. There was enormous engagement in the meeting. Some topical foci that came out. We need to have more unpacking of the issues, of key issues, like mapping barriers, defining robustness from different community perspectives. What about the ethic and epistemic issues and accountable responsibilities? So papers around that, white papers, published papers, documentation around that. Guidance and standards. What is fit for purpose? How do we get greater transparency? Preventing misuse of climate information. We need some guidance, more guidance material. There's a lot of guidance material out there already, but we need to expand on this. We need to foster new research on managing epistemic non-congruence and the underdetermination. The models are a smaller space than the full range of uncertainty. So we need to think more about that underdetermination and improve the transparency in communicating limitations to the data. If you're a decision maker, do you know the limits of value to the data? Global North Power South dynamics, that wasn't on the agenda of our meeting, but that came up really strongly. How do we deal with the dynamics of global North power imbalances? And how do we work with peer comparison when we have capacity disparity? And then the ethical dimensions. Again and again, every single session of the 3-day meeting, ethics and values came up. We have different ethics, we have different values. How do you work in the heterogeneity of value systems? When you're dealing with a scientist from the global north, dealing with an agricultural manager in the global south, for example. We have different value systems and different priorities, and there is a lack of transparency and accountability. So it's major on the agenda. This takes place in the context of a time pressure, and this makes it difficult. I hope many of you are familiar with the graph on the bottom left. The bottom left is every line is 1 year of global sea surface temperature. Okay. The middle black line is the mean. The two other dashed black lines are plus and minus 2 standard deviations from that. The orange line is last year. Last year, we went up to 5 standard deviations from the mean. 5 standard deviations, you don't even put a probability to that. It's so far out on the tail of the distribution. The black line is this year. So we have this issue where we don't know how to explain all of what's happening, but we know things are happening and they're happening fast. So there's a time pressure, there's a time imperative to respond to this. And yet we have on the right-hand side, just an example, this is the 5-day maximum rainfall changing 5-day maximum rainfall from the CMIP5 models and the CMIP6 models, and you can see quite significant differences as you go across there. Again, this issue of non-congruency of information, and yet we need to respond to this under a time pressure. So I'm almost finished. Next steps, where are we going for this? And this is an invitation to participate. This is not a closed community. The World Climate Research Programme's Regional Information for Society project has budgeted as its major item a continuation of this activity. We're having very productive conversations with donors who are seeing this as a priority, and they want to see a proposal soon on this. We've managed to trigger a cross-donor dialogue happening in the UK in June, which is very unusual to get cross-donor dialogues on coordination. We're developing proposals and concept notes developed in partnership with the donors. So it's not like a classic call for proposals. It's we're saying, here's an important topic. You say it's important. I say it's important. Let's talk about what we can do about this. And we're engaging with the broader community. So really encouraging you to keep a lookout for opportunities, because we are not trying to keep this a closed shop. This has to be as transdisciplinary and as broad as possible in its engagement, but we need to start somewhere. I'll finish with some anecdotal comments. I'm not going to go through those. I want to point to number 8. In conversations with one of the donors after the meeting, I went through to London and met with one of the leading international donors, and they said, this is the most excited I've felt in weeks. They see this as the fundamental barrier to the legacy value of what they're funding. And I'll go back and finish with one anecdote. This meeting was partly funded by the Green Climate Fund. And when we proposed them to this meeting, they said, you don't have to persuade us, we'll just give you the money. They see it as the fundamental barrier to actionable proposals that come across the Green Climate Fund's desk, because the climate case for the adaptation fund request is not justified in many cases, because the information is non-concurrent. And I'll end on that. Thanks.
Okay, well, that concludes our conference. We can all, I'm kidding. Thank you, Bruce. I mean, really a very interesting and I'm sure thought-provoking and comment-provoking talk. We are ahead of schedule now because of the one missing contribution. After we get back on track, we have 16 flash talks between now and lunch. Okay, so what's going to happen is we're going to have 8 flash talks, then have tea, and then another 8 flash talks, and then we're going to have a group exercise. But before we get to that, we've got some time. So we had 3 contributions this morning, one from Chloe, one from Mary Jane, and now from Bruce. And so I guess we're going to use this time which we've got just to engage with those three. And I'm going to pose a question to each of them, actually, because there are a couple of things I think we need to talk about. To Chloe, really, climate services is a really important opportunity, I think. And as you know, I've become converted to a disciple of climate services. This a little bit relates to what I was going to ask Bruce, because when Bruce was talking about the lack of congruence, I wasn't clear what timescales you were referring to, whether you're talking about lack of congruence on sort of climate change timescales or on seasonal, which you did mention, or even weather timescales. But either way, I'll get back to that. To Clau is the National Framework for Climate Services, which, as I say, I'm a personal strong believer in that. And you were explaining that it's complex to try to implement. I'm very interested to know from you what you think are the key barriers to us getting that. And I want to say that in the work we did with you on this, it's not only South Africa that's struggling to get climate services implemented, especially as you point out, across institutions which all have to play a role. So I'm very interested to hear what you think are the key barriers to that. And then I've got a question for Mary Jane, which I'm going to ask now. And that's really just getting back to the idea that in the study that you presented, if I understood correctly, you looked at the casualty numbers as part of the definition of what these events were. What concerns me about that is that there might be other impacts which are just as devastating as the loss of life, which might mean displacement of people or livelihoods impacted, et cetera, and I'm concerned that those kinds of extremes don't get accounted for in that analysis. And your heat map might look different if we had different criteria. So I'd be interested to know what you think about looking at extreme events in different ways. And then to Bruce, well, I've already asked the question about timeframes and timescales, but I guess my direct question is going to be, if we did have congruence between the models that you explained, what would change? Would the whole thing fall away? Because you spoke about different levels of incongruence, different kinds of incongruence, but in particular in the climate models, if we could overcome this, and I'm hesitant to use the word uncertainty because I know it doesn't mean the same thing. But if we could be more confident about the robustness of the message from the science, what would the implications be for implementation? Those are my three questions that I'm going to kick off. Can I ask? I'll just bring you the microphone and then we can pass it around and then we'll take others from the floor. Thanks.
I thought you'll finish with me. I think one of the key challenges is the coordination of these cross mandates, as we know that there are different role players having different mandates and govern differently. So bringing all of them together and ensuring that eventually we are able to work together as a community of those different entities and different organizations, including all those who are the users, has been one of the key challenge. I wouldn't, in my view, say funding is a big issue, because once you have sorted that and you are very clear with the roles and responsibilities, you are clear with the governance arrangement that can really advance that, funding would follow. But without clarifying that, and without all of us cross-organizationally being able to be comfortable with the governance arrangement, then we are not going to be able to unlock the needed resources. I think Bruce speaks of the Green Climate Fund that is willing to fund most of these things. Because I mean, the issue of climate information, justification of the project that they get at times becomes a problem, but it can, on the other side, being used as gatekeeping, not to get other certain countries to be capacitated and have access to the resources. So cross-coordination, clear governance arrangement, across the different organization and all organization buy into that governance arrangement. It's something that can, if we address that barrier, we should be able to advance its implementation.
Right. Thanks, Neville. That is an important question, which actually also allows me to clarify what that was. That is actually not our definition or my definition. That is the definition of MDAT. So there is that international database, and they've actually set a criteria that says you need to have one of the four. If you had displacements, for example, where you had at least 100 people being impacted, that would be included in that list. So it's one of the four. You have at least 10 people that pass away because of the event, or you have at least 100 people that are impacted, or you have a call for international assistance, or you have a declaration of an emergency. But we do know that that data sets really underestimates extremes that are happening in Africa. In fact, I think that it was back in 2020 where there were headlines around heat waves, because you saw both in what I showed and what Chloe showed that there's only been one heat wave that's been reported as a disaster in Africa. So to me, that just says we need to be looking at producing our own data sets, because that international one is not going to be able to capture everything. I understand that there are efforts both at the South African Weather Service, I'm assuming at the NDMC as well, to try and do this. We know SAWS has the KLAM, where they are collecting all the events that are reported in print media, and now we are expanding the definition, Dawn, I think. And then NDMC, I think they also had a system, but the reason why we used MDAT, the international one, was because it was long, and also they had a really clear definition of what made it into their list. So I think that is actually something else that contributes to why a lot of people would pick to use MDAT, and that's why we picked MDAT, because of that very clear definition. You know what you are dealing with, but you acknowledge that there's an underestimation of what's happening, especially on the African continent.
Yeah, while I pass the microphone over to Bruce, I want to say that it reminds me to say, Mary Jane, that an extreme event is not necessarily a disaster, and a disaster is not necessarily the result of an extreme event. And so we have to be careful with that language. And the other thing I've learned working in the Port of Cape Town is that even subcritical, in other words, if we have a threshold for extreme, even sub-extreme events can be disastrous. So that's, makes it complex to work with. Thanks. Bruce, so I was talking to you about timeframes and what will happen if we could fix the problem.
So on the timeframes issue, we're not talking about weather forecasting tomorrow in the next few days, but we are talking about weather, the projections of the changes in the weather. And that really comes down to seasonal, multi-annual through to multi-decadal. It's where you're making a decision that you're allocating resources against a future element. But in terms of the congruency, we're not chasing making all the models congruent. If they were all in agreement, I'd be suspicious. And if they're all in agreement, they could just as easily be wrong as they're right. What we're chasing in this mess of non-congruent data sources is what can we trust, and to what degree can we be confident in that? In other words, if I told you with absolute certainty you're going to be run over by a bus when you walk out the door, you won't walk out the door. Okay. So the change would be absolute certainty about your decisions. We're not going to achieve that. What we want is defensible confidence that what I'm doing is probably better done than not done. And we do not have measures of that. We don't have metrics of that. At the moment, the standard practice is I go to this particular set of data because I've used it before, or I know the person who generated it, or I have some loyalty factor, or my institution has a relationship with that institution. There's multiple non-scientific reasons why we choose one data set over another, or even in Africa, just because it's accessible. That's not a measure of robustness. That's not a measure of confidence for taking an action. So our challenge is, how do we build confidence for action? That's the research challenge. And at the moment, we're making no progress on that. So.
Thanks, Bruce. Look, I'm sure there are other questions for the speakers, so let me not talk anymore and see if there are any questions or comments from the floor. I'll be surprised if hands don't go up. Okay, I'm going to start and work across. Okay. Can I get a runner who wants to run?
You're doing a good job of running, Neville. Thank you very much to all three speakers. Bruce, I bumped into you and Mary Jane and in various different places, and then I listened to you and I think, well, I've heard you before, but then you always add some new bits and pieces that gets me thinking again from the start. So thank you very much for it. My question is around, where does large industry, and in particular financial industry, and in particular reinsurers, fit into this scheme of things? I can't help but think there's two parallel activities happening here. There's a scientific community, and I think that doing what we just heard, and I think it's legitimate, it's interesting, it's needed. But then there is a very large portion, or shall we say, a large community that holds significant portion of the world's wealth that is doing their own thing, especially in the reinsurance committee, to try and do more or less what we're doing at the moment here. It's just not shared with us because it has real financial advantage to get it more right than your competitor. How do we bring that into this community? Thank you.
Thanks. I see what I've done is I've pushed us beyond the time that I'll allocate ourselves to blow my own horn, so to speak.
Thanks, Neville. Yeah, again, I'd like to reiterate Baron's point. These are great talks. So, Neville, you asked 3 questions. Does that mean everyone can ask 3 questions as well? So I have to decide then. Okay, perhaps to Mary Jane, and it touches on a point you made earlier. So these extreme events have a natural forcing aspect and they have a human forcing aspect. And SAON is beginning to track the natural side, let's call it that broadly. Who's tracking the capacity that we have in society to respond? I mean, we've seen all the disasters, whether it's Cape Town, Durban, or Johannesburg, have an enormous governance dimension to it, governance failure aspect to them. Who's tracking that? And the improvements that are being made in response to those problems. Yeah. So that's
right. Can I get answers? Bruce was asked first by Baron, so I'm going to get Bruce to answer briefly, and then Mary Jane, and then we're going to move on. Thank you. Insurance sector.
Oh, yes. So I think the reinsurance sector and other industries is something we are starting to have better conversations with. We've always had conversations, but we start having more fundamental conversations with them, especially with issues that, for example, one of the arguments for why inflation in the global north, in particular the USA, is not coming down is because insurance rates keep on going up. So there are real issues behind that, and they are open. The challenge for conversations with the reinsurers and the insurance industries is trying to find compatibility of timeframes of the agenda of the actions. You know, they want something very targeted, very specific to their agenda, whereas in order to address those questions that they raise, often you have to do some more fundamental, broader work. And there's a tension there of trying to get them on board with that. But maybe the way to do it is through collaboration of the reinsurers with some of the more traditional donor agencies.
Thanks. I'm sorry, I have to get an answer from Mary Jane and we have to move on, and then we're going to leave conversation to lunchtime. Sorry.
Well, Pedro, that's a very difficult question, which I don't think should have come to me, but rather to Chloe. But I think we'll just need to look at the mandates that are available. I mean, if you look at what SAON is doing, you know, with us being under science and innovation, what we are driving is really research. And through our SARVA platform, the hope is that, you know, that platform should be able to assist just in terms of dealing with, making sure that the information is available to assist with decision making. But I want to believe that the work that Chloe has mentioned around the climate change bill and also the NFCS that was also mentioned, all of those should actually mean you've got different departments responsible for different things. Agriculture is impacted, so they have to contribute somehow. DWS is impacted. So to me, I see it as something that, you need to look at different government departments and perhaps their entities as well that would contribute in different ways. So I don't think it's a responsibility of one particular department. And I believe the climate change bill actually does give responsibilities to government at all three spheres, right? Chloe, you are nodding, I'm checking.
I thought she answered adequately, but one, the bill to strengthen the whole governance arrangement on climate change response, the three spheres, and there will be a mandate for different sectors to report, and would then have to synthesize and see how things are on the ground. But the issue of tracking, in particular the governance, you can imagine if we have to track ourselves, we are going to be subjective all the time, right? So in our reporting to the international processes, there is the entire governance arrangement that gets reported, and it gets peer reviewed before the report goes there. But if we are to track ourselves, we'll do it very well, but we'll be very much subjective. But I think you are raising a very important thing. It's a gap that you need a different voice, that can be more independent in analyzing on whether all the governance arrangements are working in place and whether they are really impactful. So it's a very interesting question that you are raising.
I'm going to have to move us along. I'm sorry, Melanie, who's doing coastal work and will have something to say about the impacts on coastal systems. You're going to have to hold that answer for us, please. And I just wanted to point out that we've got City of Cape Town's disaster management, Western Cape, is it, Johan? City of Cape Town disaster management, who's at the other end of the process, dealing with the sort of front end of these events. Which we'll hear from later. All right, so let's try this. The flash talks. All right, so we're going to go for 8 of them. Got my little timer here. And the first one is Helga. Are you ready, Helga? You are. Okay, so we need those flash talks. There it is. And you can scroll through it, I believe. Can you? How do you scroll with this thing? Am I doing it? I am. Okay, so you can scroll through your post if you need to. Testing. Yeah. If you.
Okay.
Yeah, okay. So backwards and forwards like that. Right, good luck.
Thank you. I need it. Good morning. Thank you for the opportunity to talk today about the extreme events. So I'm a PhD student at the Udvar University in Hungary, and I am using the Codex data to try to understand the extreme indices based on the temperature and precipitation. So for this study, I was really excited to see this, as it's my first opportunity to present in South Africa, because South Africa is among the most vulnerable regions to the effects of climate change. And as we have heard from the previous speakers, we have already experienced a lot of severe events, even greater than predicted before. So based on this study that I have prepared for this presentation, we see that there is an expected change in the future. For this, we use the RCP 2.8, which assumes the immediate mitigation, and the RCP 8.5, which is the non-mitigation scenario. So for my study, we chose the near future, mid-future, and the end of the century. So we see that the how do I point? Okay. Most of the interior of the country would experience above 4 degrees Celsius at the end of the century under the RCP 8.5, which assumes no mitigation, business as usual. And even though the coastal areas will experience a less intense increase in temperature, they will still experience about 2.5 degrees Celsius increase in temperature based on the RCP 8.5. So our results do agree with the CMIP 6 CMIP 6 projections, as we saw from the previous presentation, which do confirm that there will be more intense and more severe extreme climate. So for illustration here, I calculated the hot days indices, which is defined as the number of hot days where the temperature exceeds 35 degrees Celsius. And we see that there will be an increase. Okay, I'm just going to, okay, no. I wanted to show the graph. Anyway, I will just explain it. We see that under the RCP 8.5, there will be, amazing. Under the RCP 8.5, there will be nearly doubled increase in number of hot days compared to the RCP 2.5. And our base period is the 1981 to 2000. So we see that the increase in number of hot days just steepens with time. So the mid-century would experience about 1.2 increase compared to the RCP 2.6 in the non-mitigation scenario. And while at the end of the century, there will be about 1.8, which is nearly the double change that I was referring to. While the precipitation data presents some uncertainty, I can clearly state that there will be a drying trend there will be more drying trend expected by the end of the century. So I focus more on the RCP 8.5 because it is the non-mitigation scenario. And while the RCP 2.5 does not really show more change. For this study, I am more interested in the Western Cape because this is where the wine regions are. And I am focusing more on the effect of climate change on viniculture. But for the purpose of the study, I will just explain that. For a more detailed explanation, so we see that the Western Cape will experience about 20 to 100 increase in hot days by the end of the century under the RCP 8.5 and a decrease in temperature by 40 to 60%. This will result in more consecutive dry days and more frequent droughts. So according to the study, I can positively say that climate change is no longer a future threat, but it is our present reality. And we need more robust mitigation strategies and adaptation strategies that will help us try to mitigate and hope for a better future. And with that said, I would like to thank you one more time for the opportunity to present again. And if anyone has questions or suggestions, I am more than happy, as this is an opportunity for me to learn as a new scientist who is especially not based in South Africa. And I am grateful to have this opportunity to be connected to the South African experts. Thank you.
Thanks very much, Helga. You are our first guinea pig in trying to do this in 5 minutes. You didn't do badly. Okay, so we're going to press on. The second one, Flash 1.2, is Peliwe. Where's Peliwe? Peliwe, there you are. Okay, good. All right. So she is all set. Okay.
Smart. Okay, so morning, everyone. Okay, morning, everyone. I want to go down. Okay. Ooh, I went down too far. Now I'm going down. No, it's not showing. me.
Hey, he got it.
Okay. Are you scrolling down for me? Okay, you can just keep it up. So the study I'm going to present to you today investigates the interannual variability or trends of temperature-related indices. And the focus is on heat waves and extreme hot days over the Limpopo River Basin. And I'm looking at the atmospheric circulation patterns that are conducive to those conditions. So the first part of the methodology involved using RClimeDex, which is a software package that performed a regression analysis of the temperature-related indices at individual stations. And those stations were 9, and they're in that table. And then the second part of the methodology involved the use of self-organizing maps, which is an unsupervised machine learning technique. And in this case, it was used to investigate and visualize atmospheric circulation patterns of extreme heat days and heat waves. And then that was displayed in the diagram here at the bottom. It had 20 nodes, which was showing the atmospheric circulation patterns during austral summer. Can you scroll down for me, please? So just slightly up. So the first part of the results, again, slightly up, shows that the RClimeDex in its analysis of temperature-related extremes shows a more warming and less cooling local climate, which is evident across those temperature-related indices. And this warming has led to notable increases in the percentage number of extreme hot days and the duration of heat waves annually. So mostly the heat waves that were discovered were lasting for more than 6 days. And then looking at the atmospheric circulations of heat waves and extreme hot days, it was found that the South Indian high pressure system coexisting with a mid-latitude pressure system were the most prevalent atmospheric circulations for heat waves and extreme hot days. And those are represented by nodes 20. Scroll down at the bottom. Nodes 20 and 17 and 20 and 18. So the conditions created by these systems are hot and moist air advected from the warm Indian Ocean. And because the systems were strengthening with height, and a high pressure system is associated with strong subsidence, those warm, moist conditions were retained on the surface for longer periods. And then the other atmospheric circulation patterns included the South Atlantic high pressure system and the South Atlantic high pressure system existing near the surface and at the upper level. And that is represented by nodes 3 and 1. And the conditions created by these systems are hot, dry, and clear skies because the South Atlantic Ocean is dry compared to the warm Indian Ocean. And then the other one in atmospheric circulation patterns included the South Indian high pressure at a near surface and the South Atlantic high pressure at the upper level. And the conditions were very hot and humid because you still have a South Indian high pressure advecting moist air from the Indian Ocean, and then you have this high pressure system creating subsidence and retaining those conditions at the surface. So the other thing I explored was whether the positive trends in heat waves and extreme hot days were responding to any trends of these atmospheric circulation systems that I've just described. So interestingly, these atmospheric circulation systems have been decreasing over the years, which is in contrast to the positive trends that we have seen in heat waves and extreme hot days. So this points out to that there are other contributing factors responsible for the positive changes in heat waves and extreme hot days over the years. And those could be the local climate feedbacks, the ENSO episodes, and anthropogenic forcings, but those are beyond the study of this paper. Yeah.
Thank you very much. Thanks very much. Okay, thank you. Just to speakers, try and avoid keeping this button pressed because you'll take the eyes out of all the audience when you're gesticulating. Okay, so number 3 in our hit list here is going to be presented by Adrian for his colleagues. No? Yes.
Yeah. Good morning, everybody. Yes, I'm Adrian from Welt. I'm from the Department of Geography at the University of the Free State. And yeah, the paper that I'm going to present on is one of my master's students, so he could not be here. So hopefully I'll do it justice. So what we did, and he's still busy with his master's, so this is just one of his publications this far. We looked at 8 weather stations in the Northern Cape. And we tried to evaluate if the AG Era 5 data set represent the mean summer temperatures and mean winter temperatures. How does it, is there correspondence and what is the biases? And also looking at the seasonal heat wave and cold wave characteristics across the Northern Cape. Among the weather station data and then also the AG Era 5 over from the 1980 to 2020. So what we found is that among the different the AG Era 5, there's only the means, if you can see in the box plots there for the mean summer temperatures and mean winter temperatures. The average is only less than 1 degree that the two weather station, the weather station and the AG Era 5. So there's not a great bias in the two data sets. If we look at the extreme temperature, extreme events, the heat wave and cold wave characteristics, we looked at the heat wave number and we looked at the heat wave frequency and the heat wave magnitude, as well as the cold wave number, cold wave frequency and cold wave magnitude. And what we found there is that the AG Era 5 in all instances overestimate. However, the biases in that overestimation is very small. So in general, we can use the AG Era 5 data set in data sparse areas, especially in mountainous regions as well, where we do not necessarily have a weather station to present or get the data from. So I'm going to keep it short, sweet and short, and we can talk afterwards. Thank you.
Thank you. Thanks, Adrian. So again, this is a way for us to make sure that we really listen to what's going on and that we can get the information succinctly and have opportunity. So reminder, all of these posters are in the ebook. The plenary talks we will still make a plan with. All right, so this then brings us on to the 4th one, and this is Willem, who's known to us all, especially me. Willem, the floor is yours. No. Okay.
Good morning, everybody. This talk is about some of our seasonal forecasting efforts at the University of Pretoria, and in particular, our efforts to predict El Nino and La Nina events. And so we will see the logo of our effort on the left called Seasonal Forecast Works, and we started this in 2016. So since then, we've had now 9 El Nino and La Nina seasons. And here's an example of the products for the 23-24 El Nino. First of all, we see the global sea surface temperature forecast in terms of sea surface temperature anomalies. That clearly shows the El Nino event. Associated with that is a specific reference to the Central Pacific Ocean that best describes the El Nino events and La Nina events, and also the area that's most directly related to our seasonal rainfall over Southern Africa, summer rainfall, I should say. And on the top right, you see a probabilistic estimate of what the likelihoods are for those different kinds of events to occur, namely El Nino, La Nina, and Enso neutral. Now, how do I move this up? Okay, stop. Thank you. On the left, you see a probabilistic verification of how skillful we are able to predict these events. First of all, without going into too much detail, the so-called rock plot, my favorite skill estimate parameter, shows that we are indeed very able to discriminate El Nino events, La Nina events, and also Enso neutral events. And how reliable are the probabilities that we associate with these forecasts? This is reflected in the so-called attributes plot that shows that even the reliabilities associated with these events is really skillfully predicted. However, when you look at these so-called Taylor diagrams, where we show different forecast systems that we use in order to construct the so-called multi-model ensemble, shows that we are having great difficulty in capturing the variance of these events. In other words, even though we can combine models and produce better correlated forecasts with observations, we are still having some difficulty in trying to capture the real extremities of these events. So can we really capture very strong El Nino events and very strong La Nina events? And if you can scroll down to the bottom of my talk, you'll see some estimates of what we have done in terms of, it's not really estimates, these are real forecasts that we have produced over the 9-year period from 2015-16, and forecasts produced as far back as 5 months ahead of the December, January, February season, when you see these events becoming to fruition and reaching its most intense stages. And we see that for the most part, the real time forecasts have unfortunately the same characteristics. We seem to be able to differentiate these different events, but we are still having some difficulties in capturing the real extremities, the really strong El Nino events. However, the recent one we just had seemed to have been captured really skillfully. Now, so what we will do next in our collaboration with our modeling partners at the CSIR is to see if there's going to be really an effect of making these extremes a bit bigger on how that may influence modeled circulation patterns over Southern Africa. And for the next conversation, we will hopefully be able to present those results. Thank you.
Thanks. It is working quite well, I think. A lot of information still. What's swirling in my mind are the kind of different approaches to the different timeframes and particular kinds of events, and how we are able to predict the kinds of events, like the El Nino being the sort of context in which these extreme events happen. So anyway, that's me editorializing against my own rules. Okay, so next, Peter Marsh is there. Hi, Peter. And I will give you the floor. Slip this piece of paper out from underneath. Okay, all right. There you go.
How do I,
Pushing the button.
should I just ask which scrolls?
Yeah.
Okay, hello. My name is Peter Marsh, and I work as a researcher for the Climate System Analysis Group at UCT. specifically on the DSI Africa Heat Center project. And today I'm presenting my poster, Implications of Sampling Bias in Satellite Data for Use in Heat Wave Monitoring in Developing Economies. I know I only have 5 minutes, but I think it might be more interesting for some of the audience just to first introduce the broader project that this forms a part of, which is the DSI Africa Heat Center project. It's an interdisciplinary effort seeking to create a data science ecosystem to support extreme heat and health research. So for better or worse, it's really a data-driven project. And a cornerstone of the project is the work being done to find, acquire, and retrospectively harmonize a diverse range of clinical trials data. So the ultimate goal here is to really relate climate information to this highly detailed human health information. The project has 2 focuses. The first research project considers prenatal, so pregnancy cohort data across the full sub-Saharan African continent. And the second is 2 urban case studies in Johannesburg and Abidjan on the Ivory Coast. And this utilizes more generalized clinical trials data, largely from HIV or COVID trials. And the aim of RP2 is to quantify the relationships between negative health outcomes and extreme heat, as well as socioeconomic vulnerabilities. So this work I'm presenting today is really focused on this second research project, where we're looking to accurately quantify the heat exposure a patient may have experienced. So given that, we have the need to create an appropriate climate data set to compare with this health data. And an interesting sort of aspect of it is because the health data is human personal identifiable data, we can't directly share that data even within our group. So we need to link climate data at an early stage, and then it'll need to be both spatially and temporally anonymized. So we really only have one chance to do this, and we really need to ensure this climate data that we're associating with it is robust and correct. So we have 2 requirements. One, the data needs to be of a high enough resolution so we can delineate between a patient living in Alexandria or Sandton that may be experiencing different heat profiles. And second, it needs to be temporally, have a temporally continuous. So we need to delineate a patient may have experienced a higher heat profile this year than the previous year. And this is where land surface temperature really comes in and has been proven very effective in previous studies in identifying urban heat islands. So you can sort of see the promise, in this figure 1 at the top here, we have ERA5 with a 27-kilometer resolution, then Meteosat, which is offering a 3-kilometer resolution and hourly observations, and MODIS, which is really high resolution at 1 kilometer, but then we only have an observation 4 times a day. A key stumbling block that's sort of why it's difficult to move this land surface temperature and work with this data beyond just spatially mapping and to move it into a temporal domain is it's gappy. But essentially, every time there's a cloud, we can't see through the cloud, and then you have missing data. So just the figure on the left there just highlights that. When we look at the large timescale, you can really see the seasonal cycle, even perhaps differences between years. But when we drill down and look at monthly data, there really is a lot of missing data, and that varies across the seasons. If you could scroll down a bit just to that second figure, thanks. So that the second figure, obviously we talk about land surface temperature here. We don't live lying on the floor. We need to consider air temperature. So first, just considering land surface temperature on the x-axis, air temperature on the y-axis, and we can see there is a strong relationship between it, and it is feasible to go from one to the other. But the second we need to consider is there's the sampling bias from the land, the remote sense, the satellite data, that we aren't getting observations during cloudy periods. So in the blue in the background, that's ERA5 measurements, when Meteosat does not get a measurement. So we can essentially think of those as cloudy measurements. And it's perhaps not surprising that a lot of the really cold conditions happen during cloudy periods. What is interesting is in the top right of the figure, there are a number of extreme heat. In fact, the hottest periods, Meteosat hasn't got an observation, perhaps associated with thunderstorms or something. The orange is ERA5 when we do get a measurement from Meteosat. And interestingly, I think Adrian touched on it, is ERA5 does actually do a really great job, and the Meteosat measurements are very similar. And then the pink, just to highlight the sampling bias and difficulty working with this data, is if we just naively take the daily maximum land surface temperature from Meteosat and compare it to the air temperature. Of course, we completely get these spurious results when the maximum land surface temperature is obscured during the day, and we end up taking a measurement at a different time of day. If you can scroll down to the last figure. So I've been working with a lot of health data for the last year, and it's really entered my thought process. So we need to sort of assess whether this land surface temperature is useful. So I've been looking at a lot of other people's clinical trials data. I'm hard. Okay, I'll go very quickly. So I designed, as a climate scientist, we design our own clinical trial, and it just so happens that each patient happens exactly at a weather station for a 7-day period, and we consider the heat profile associated to each patient over that 7-day period from the different data sets. And of course, we're comparing apples to oranges here, so we've scaled the data, so the patient with the highest exposure score is 100, the lowest is 0, and through this we can compare our observed station data to ERA5 as well as the various land surface temperatures. And interestingly, again, the ERA5 does a really great job in the clear sky conditions. I mean, ERA5, MODIS, and METEOSAT are all largely identical. Of course, the variance is really low here, and I think that's just because 7 days of clear sky conditions are just oversampling winter conditions. In the random population, you could maybe make an argument that MODIS is better capturing this sort of bimodal structure, because the higher resolution is able to differentiate between one suburb to the other. Yeah, I'll leave it there. Sorry for going over.
Thank you. Thanks. So again, range of time scales and space scales. It's really about scaling that is something which we need to think about. Sabina, there you are. Hi. I know the names, I don't know the faces. There's people I've been meeting over the last couple of weeks. Thanks, Sabina. You're up.
Thank you.
And there's 2 more after Sabina before tea.
Okay, hi, I'm Sabina from the University of Cape Town, and I'm looking at exploring the value of high-resolution climate model simulations for heat information within Johannesburg. So increased exposure to heat has many impacts, including negative health impacts. And this study forms part of the broader HEAT project, which Peter already introduced to us, which aims to explore these health impacts over African cities and to provide valuable information to decision makers. And so with this in mind, in order to do this, we need high resolution climate data on both temporarily and spatially. However, observed station data often lacks the spatial density required, and satellite data provides surface temperature, not air temperature, and is often temporally patchy. So often a high-resolution climate model can be used to bridge this gap. And so with this in mind, this study aims to assess whether a high-resolution climate model, namely WRF, can be used to provide valuable information for heat over Johannesburg. So this study did, as a preliminary assessment, did 3 WRF simulations. The first one was a WRF simulation with a single-layer urban canopy model. The second one with the WRF simulation with the same urban canopy model, but increasing the albedo of the rooftops within that urban canopy model. And then the third one, a simulation without the urban canopy model. And so our preliminary results, firstly, we used 96 processes to do these simulations. And just by extrapolating from these were very short simulations, 4 months. From extrapolating from that, we found that for a 10-year simulation, it would take 27 days, 27 computing days. And so this may be a bit unsustainable in terms of computing resources. So one of our ideas was to run shorter WRF simulations and then feed this into a machine learning algorithm. And this may be more efficient for providing a high resolution temperature data set. But our thinking is that we must therefore assess whether WRF is able to firstly capture the spatial pattern of surface temperature, and secondly, whether it's able to capture the relationship between surface temperature and air temperature. And so the preliminary results show, first, we're looking at this figure in the top left, we're looking at comparing the WRF simulations to the satellite data to see whether it's able to capture the surface temperature pattern. And we found that both when we compare, we also want to make sure that WRF improves upon our Error 5 reanalysis, whether it's worth doing these higher resolution simulations. And so we find that when we compare Error 5 and WRF to MODIS, they both perform kind of equally well. And then when we compare, sorry, to Meteos, to MODIS, they both do very well. I mean, Meteosat, and when we compare WRF to MODIS, the higher resolution satellite, WRF actually performs better and is able to represent 4 times as much of the spatial variability when compared to Error 5. However, when we remove the urban canopy model, WRF performs even worse than Error 5. So from this, we can see that the urban canopy model is important and essential. Next, we looked at just one single station in Johannesburg to see if, as a preliminary result, if WRF is able to capture the general air temperature. And if we look at figure 2, sorry, up a bit, WRF actually underestimates the higher temperatures. And when we increase the albedo of the rooftops within the urban canopy model, the temperatures are only slightly decreased. Oh, I'm going over. Okay, and quickly we then looked at the relationship, where the WRF is able to capture the relationship between surface and air temperature for different wind regimes over Johannesburg. Again, sometimes WRF improves upon Error 5, but mostly both WRF and Error 5 show much steeper relationships than observed. And so to conclude, WRF does show value in representing the spatial variability of the surface temperature, but a lot more simulations are needed and a lot more observed data is needed to really further evaluate whether WRF could be valuable for this project. Thank you.
Thanks. Your book, Sabina, is yours. It's incongruous results coming from TSAC. Okay, we've got 2 more contributions before we break for tea. And Kaniso, you all set? Yes, that thing.
Good morning. Thank you. In 5 minutes, we do not want to replace the SPAY, but we thought the simple moving average method used to calculate the SPAY could have problems because we lose data at the edges and we are not sure about the sensitivity of that. So we started to test the performance of Savitsky and Golai filter, which uses, polynomial fitting and also windowing to sort of recalculate the SPAY. So that's what I did in this work. And then I'm now comparing, I took the data from the airport here in Cape Town and compare the SPAY used to the SPAY calculated by Savitsky and Golai filter and the simple moving average. So this is the one that this is the one that I calculated. And of course, we have data here and maybe we have a different sensitivity. The small Python code, because you need to do polynomial fitting. The Savitsky equation uses polynomial fitting and simple moving, and windowing. So you need to have a small slider in the small Python code to sort of fit and get the best fit for your Savitsky equation. So that's what we did here. And other than that, the reason why we did that is because we were, the South African Weather Service has a lot of rainfall and other data sets that we can use to calculate indexes like SPAY and others, agricultural indexes and stuff. And we started to calculate those. We're thinking that, instead of you getting met data only, you can also get these SPEI and SPEI, or if there's a stream flow, you can also get SSI and stuff like that. So that's why we did this. And then we also do it spatially, sorry, using CHIMS, GPM, and all those other centers. And then the soil to rain model, or SM to rain model, is a reverse hydrology model that we are also using to estimate rainfall from soil moisture. So you have satellites, or you have a probe that you use to measure soil moisture, and we take that and we can estimate, for instance, how much water you use for irrigation and stuff like that. But in the satellite data, we can also map, for instance, like SMAP or ASCAT, all those satellite sensors. The influence was from the guys from Italy, Branco, who actually started this. So we have been also seeing if we can't do that, because it's an option also. You can combine these two other data sets to create your own reanalysis data and stuff like that. So this is the map that we created, global map, but we normally concentrate on South Africa and maybe take it closer to the station. We depend on the grid, of course, the resolution of this data. So here we were showing how it compares to, for instance, different sensors. This is the soil moisture to rain data, CHIMS, this is GPM and gauge data. We took it in GraphRenet here, and you can also take it anywhere. I tested the performance of this model in the Cape Point, in the Cape airport data. Of course, there the model, the soil moisture is not so good because of the paving and stuff. So the model will not do as good as taking it over Pongola, for instance. But of course, in Pongola, you detect irrigation because they do irrigation of sugarcane and stuff like that. But it's data that is working, you can use it. And then we also, so if we play around with this data and it's a bit boring, so we wanted to now forecast it. We see if we can forecast SPI or SPEI or SSI, all these indexes. We're using machine learning and stats models. But in this study, we are showing that if you are using hybrid, if you are combining stats model for non-linearity and linearity of the stats model and deep learning models, the models tend to track, these data-driven models tend to track these drought indexes or these indexes very well. So here we use directional symmetry, R-squared, and many other performance statistics to sort of compare the performance of these models. The test data that I use here is Cape Airport again, and you can see these are different data-driven models that we designed. We do not normally design these. Okay, maybe the interesting one is this one, which used a Saviscan Golai filter and combined ARIMA and LSTM, which is a deep learning and stats model. And you can see it performs very well, and its directional symmetry is also very good and stuff like that. So if you want to see this, maybe it is there in my computer if you are interested in using this data or the models.
Thanks, Nkangisho. Some very innovative approaches. So this brings us to our final flash talk before tea, and this is Hector with a range of other authors. Okay, there's a little.
How do you scroll them down?
Just point it. Look up at Duncan, and he'll scroll for you.
Okay.
There's a. Thanks.
All right. Thank you, Neville. Good morning, everybody. My name is Hector. I'm presenting this study on behalf of a number of authors, two of whom are here. We considered an extreme low temperature event that occurred during July 2021, which affected the entire subcontinent, actually, the entire SADC region, but we focused on South Africa. And this work has been published already in the journal Weather and Climate Extremes. So we focused on a specific event based on the fact that it broke 27 long-term records For context, for those from the Northern Hemisphere, our temperature extremes, we lie between 22 and 34 degrees south. And therefore, the records that you see in the table there might not seem so exciting to you if you come from extremely cold climates. But we did have temperatures that were broken during that time. So it was interesting to understand why it was that you had so many records, long-term records, broken. This is despite a warming trend, as you see on that time series. Of course, that time series is based on temperature anomalies based on a 1991 to 2020 climatology, not based on pre-industrial climatology. And so what you see on the left there are the blue stars here showing locations of they are showing locations of stations where temperatures were broken, which is pretty much much of the eastern half of the country. These were the records that were broken. We have also looked at, in terms of long-term trends of ground frost, which has also declined. So we sought to understand what caused this particular event. This is despite a warming trend, and I think you have seen in the other talks that most of the talks are really talking about heat extremes, heat waves. And what happened? How did we have? And this was at the beginning of a coronavirus pandemic, when it was not well understood how extreme cold events would affect the transmission of COVID. And so it was during that time there was snowfalls, disruption of transportation, disruption of economic activities. So we sought to understand the dynamics. And if we scroll down, we will be able to see what was interesting. If we scroll to the figures down there, we will, of course, be able to see a prominent cold front. That's not too surprising, a prominent cold front. What, of course, is interesting to forecasters who might be here is this field of cold air cumulus. If you are a forecaster on the bench, a few of you have been, if you see this coming, this type of popcorny cold air field of cold air cumulus, you need to set up a warning for extreme cold conditions. So what was interesting is that we did have breaking of, we did have a combination of a cold front. We had in the upper air an interesting feature, what we call a cutoff low here, although it was offshore. And then we had at the surface a region anticyclone, which had a long fetch driving cold air from the Southern Ocean. What was interesting also is that we do not normally get cutoff lows that are offshore influencing the weather over the country. This intense cutoff low extended to the surface, creating a strong southerly flow from the Southern Ocean that then drove, and of course, this flow was also moist, and therefore we ended up with snowfalls, especially over high ground. So a combination of three systems, cold weather systems, a raging anticyclone at the surface, an intense cutoff low that extended to the surface, allowing advection of cold and moist airflow from the Southern Ocean. All combined. Of course, if you look at other processes that occurred associated with this cutoff low, you would talk of Rossby wave breaking and as well as tropopause folding. When a Rossby wave breaks, you tend to have folding of the tropopause, you tend to have dry and colder air from the stratosphere intruding into the lower troposphere. So as I've said, just to conclude, we considered this one event, which was extreme in its nature because it broke records, but we are also developing a follow-up paper where we'll present and develop a typology of such events using machine learning algorithms.
Thank you, Hector. Okay. Thanks, everybody. So, yep, we're 7 minutes behind schedule, which is not terrible. We'll take it out of lunch. So the idea here is that, you know, we get a sense of who's doing what are the various interests, and you've got the information, the contact details, and you hopefully know the people are, use the opportunity to engage. We'll call you back from tea within half an hour, and we'll listen to 8 more inputs. I think it's 8. And then we're going to do our first group exercise, which we'd like you all to participate in, and we'll direct you on that process. So let's break for tea now. Thanks.
To have 8 flash talks, and 2 of them are going to be remote. So the first remote one, we will be starting with it, is being led by Sarah Rofe from the ARC. You can proceed with the video.
Hello and welcome to my presentation. I'll be focusing on extreme temperature events, and particularly extreme hot temperature events, which are heat waves and warm spells. And these types of events can have significant impacts. And in an agricultural context, they range from crop yield losses to crop yield failures even. This can cause impacts on, this can impact the crop yield quality. This can result in reduced water availability, so water stress. And for livestock, a significant impact is heat stress amongst livestock. But an underlooked and an understudied aspect is that of the impacts that extreme heat can have on farm workers. And this is the one big reason as to why this case study focuses on the abnormally hot conditions of January 2023. So from about 9 to 23 January, there was a prolonged period of abnormally hot temperatures. So here on the right, we have temperature anomalies, and you can see from the 9th to the 23rd, temperatures were anomalously warm and up to about almost 2.5 degrees for the area average temperature anomalies. This event was likely associated with an anomalously strong Botswana high pressure system. And here below this graph is an average figure of the Botswana high pressure system at the 500 geopotential level from the 9th to the 23rd of January. So this event is important because, of course, at least 5 farm workers died around the 18th of January. And what we're trying to do at the Agricultural Research Council is we're trying to see how we can use the WAF model to simulate extreme heat, and in turn to inform the development of a forecasting system. We currently have it in place, but we're still trying to develop it and improve on its accuracy as we go. So here we've used the CFS 6-hour reanalysis product. We ran a simulation from the 3rd to the 31st of Jan. We used this simulation domain in figure 2, and it has an 8-kilometer resolution. And here are details also of the physics. You can select the link, and that can provide more information on the physics. Nonetheless, in addition to this, we also use the Error 5 reanalysis as an evaluation data set. So you have some results from the 17th to the 20th of January for 2-meter temperatures and 500 geopotential heights. And what's key about this period is that it's quite a number of days, more than 10 days after the simulation was initiated. So that means that model drift can play quite a substantial role in the performance, in addition to the boundary conditions as well as the physics we selected. So from the 17th to the 20th of Jan, we see pretty decent performance in terms of temperature. However, some underestimation is here over the southern coast for the 17th and 18th of Jan, and more so over the confluence between the Northern Cape, so over South Africa, Botswana, and Namibia, we see that the WAF model was seemingly overestimated temperatures, but still fairly good magnitudes and a reliable representation. But for the 500 geopotential height, what sticks out the most is that the placement of the Botswana high pressure system is very, very different across the the WAF simulation and the Era 5 data. So clearly this suggests that maybe there's some boundary conditions or physics issues in our simulation. So of course, we need to improve on this simulation. However, the temperature results suggest that with improvements, we can use the WAF model to provide us reliable simulations of extreme heat. This provides us validity of the daily forecast that we're using, except further validation is required. So here I've presented on the WAF model results, and they're quite promising, but sensitivity tests are still needed so that we can determine an optimal configuration to produce the most reliable results. This is, of course, ongoing work, and we're undertaking a whole bunch of different simulations. There are some cold event simulations, there are some extreme rainfall simulations, and all of this is towards improving the accuracy of the forecasting system that we are developing. And what's important is to consider the application of this forecast. And Figure 5 provides an example of this. And for us, from these heat simulations, we're looking at thermal comfort or discomfort levels during extreme heat and even extreme cold. And this represents one of our ongoing product developments at the ARC. And all of these simulations, event-based simulations, are contributing to these product developments and the improvements in our daily forecasting system. Thank you very much.
Modeling there, I think the foreseeing fields are an important aspect to consider. So our next speaker is Lynette. Yeah.
Okay, thank you. Good morning, everyone. Can we please move to the bottom of this page for me to start? Now, Hector already talked about July 2021. Now, I want to tell you a little bit more about December 2021. Can we move down to see the bottom figure, please? Yes, thank you. So during December 2021, there were a few unusual things as far as the weather is concerned. Firstly, it was a very wet summer month. So you can see on the rainfall anomaly map that a large part of the summer rainfall area received above normal rain, but also the very dry western and central interior. In some places, more than 300% the average rainfall were observed. So places like Koffiefontein in the Western Free State on average receives about 50 to 60 millimeters of rain, but they had 248 millimeters during December 2021. So it was a very wet year, very wet month. That also resulted in crop failures over the farming areas in the maize production region over the central parts of South Africa. It resulted in a brown locust invasion over the dry Karoo areas in the west. So there were also more than 80 deaths as a result of heavy rain. And later in January, the summer rainfall area was declared as a disaster region, especially the central parts, as a result of the heavy rainfall. And then what was also different about December 2021 is that the environment was extremely favorable for thunderstorm development. So the mid-level winds were stronger, it was more unstable, and there was more surface moisture. And then what we also saw was that there were more convective dry lines. Now, if we can move to the top of the slide again, I want to show you what a dry line is. So dry lines are regions over the Southern African plateau where the moist air, mostly from the Southwest Indian Ocean, comes in contact with the very dry air over the Karoo areas and the desert areas in the Kalahari and the Namib. And we call this line where the two air masses intersect, we call that a dry line. So on average, there occurs about a dry line daily during December months. So dry lines occur really frequently in December, but we wanted to know how often are they convective? How often do these dry lines result in thunderstorm development? So that's really why we're interested in dry lines, because often thunderstorms develop along them. So during a study between 2010 and 2021, where we compared lightning data with dry lines, we saw that on average 12 of these dry lines during December's are convective, so they result in thunderstorms. But during December 2021, 20 of the dry lines resulted in thunderstorm development. And because of the very favorable environment for thunderstorms, that really resulted in a lot of thunderstorm activity during this month. So here's an example of one particular day on the 15th of December, where a supercell thunderstorm, which is one of the most severe types of thunderstorms and also the most rare type of thunderstorms that we see in South Africa. And this often produces severe weather, such as large hail or damaging winds, even tornadoes. And this supercell developed on the border of the Free State and the Northern Cape. And due to the strong winds in the atmosphere, it was then moved across the Free State province. And as it moved, it became a mesoscale convective system, just another organized form of thunderstorm. And it moved across the province. It caused damaging winds in Tabanshu. Radar data also show that damaging winds were possible all the way along the border with Lesotho. And then later that evening, it reached the Eastern Free State, where it also caused large hail. So that's just one example of a thunderstorm that developed on the dry line and how it was moved during this very favorable month for thunderstorms across the interior and caused a lot of rain and damaging winds as well. So in conclusion, we've found that convective dry lines contributed significantly to the large rainfall amounts that we saw over the drier central and western interior of South Africa during December 2021.
Okay. Thank you, Lynette. All right, we are only 3 minutes over with our time, so I think we are doing relatively well. So we will have another video, and I think with it, in terms of time, we don't really have much control.
Hi everyone, I'm Tanya Haupt, a researcher from the Department of Forestry, Fisheries and the Environment, Oceans and Coasts. One of my core functions at the DFFE is to research the effects of changing climatic conditions on selected benthic invertebrates. An example is how different thermal regimes or pH conditions affect the physiology of important resource and keystone species, such as abalone, West Coast rock lobster, and Cape sea urchins. Part of this research entails monitoring the environmental variability of the microhabitats of these organisms over time. And this data assists us in choosing the most appropriate treatments in our experiments, and our experimental findings can also be related back to the field conditions or what organisms are actually experiencing in their natural habitats. Besides gradual changes in climatic conditions, we are aware that extreme events like heat waves or cold events and even flooding from storms are on the rise and have become increasingly important stresses for organisms inhabiting inshore or coastal areas. And this is particularly true for sessile or semi-motile invertebrates, since they cannot readily escape. Our poster captures our long-term monitoring efforts in Elands Bay along the west coast. Here, low oxygen events are common due to algal blooms, whereas low pH conditions already exist from upwelling and low oxygen events. Additional exposure to extreme stresses can further exacerbate impacts on physiological processes. For example, acute thermal stress may cause a rapid deterioration of cellular processes and performances beyond tolerance limits, affecting survival, growth, and development. Data on temperature extremes are therefore important to design experiments and calculate thermal windows. We initiated long-term monitoring in 2022 by deploying temperature loggers in microhabitats, such as intertidal rock pools, shown in Figure 1, sun-exposed and subtidal areas. And from this data, we are interested in the extreme minima and maxima temperatures found in these various microhabitats, which you can see in Figure 2. We also captured events of a series of floods as a result of heavy rainfalls that occurred in September 2023, during which time a steady flow of fresh water had broken through from the nearby estuary. What we observed and captured in Figure 3 was a complete transformation of some of our rock pools with the steady flow of significantly warmer estuarine waters gushing through them. We know that these events not only result in significant temperature changes, but also dilute seawater inshore, causing organisms to become physiologically stressed. So besides temperature, the flooding event emphasizes the need for monitoring of other environmental parameters in the Elandsbay area that may vary with extreme conditions such as salinity, pH, and dissolved oxygen levels. Moving forward, in June of this year, we will be deploying dissolved oxygen meters within the bay that will hopefully give us a better idea of the extreme low oxygen events in the area. Thank you.
Okay, great. So we are really getting a mixture of topics there, which is really great. Then we'll move on to our next speaker, which is Mohau.
Thank you very much. So I'm going to present on the work that has been done by a number of co-authors within the CSIR. And this follows a book chapter that was drafted as a review of work that is done on attribution and detection in Africa. And we just decided let's expand on this work just to have a sense of what can be done along the lines of detection and attribution of fire. So if we were to, I don't know how to manipulate this one. Up, yes. So the feedback that we obtain from the disaster management here in South Africa is that when it comes to management of fire, there is a challenge in the sense of the shift in the seasonality. If you go up again. So, and also we did an analysis. We did an analysis just to check if we can see any climate change signal when we look at the fire weather index. And it turns out if we calculate shifts along 30-year periods, it becomes obvious that there's a likelihood that areas that would not necessarily be having a strong signature of fire weather tends to also have a shift towards a higher likelihood of getting those areas being having an increased chance of fire weather. And the question that comes often when you have fire events from the public is, can we associate this with climate change? And this is when it becomes obvious that there is a strong public interest in attributing fire to climate change. And often when these questions come from the media, our answer is we need to do research along this line, which is an impolite way of saying we really don't know yet. So, but of course, we cannot end there. We need to start making efforts. So what we did was just to check from the literature the methods that I established in terms of being able to attribute the fire events to climate change. And there are a number of schools of thought. They go along the lines of thermodynamic approach, storyline telling approach, and general statistical approach. So what we did here was just to pick one variant of those approaches that are used and try to answer the question of whether the drought that we experienced in 2018, can we make any attribution statement if we were to go up? From that left, you can clearly see that it was a more general drought that was experienced. And we applied this thermodynamic approach where you basically look at the envelope when there are natural forcings from a climate model, and also when you switch off those natural forcings, just to see if there is a difference in the distribution against the threshold at which you are actually seeing your drought. And it turns out the difference between those distribution is not really pronounced, which means actually that drought, actually the probability distribution is within the climate variability that is experienced in the region. But of course, when it comes to now learning from this drought analysis and checking if we can feed back into fire weather, it becomes obvious that we need to actually run experiments that avail all the parameters that you need so that you can be able to do similar analysis, because the fire weather indices are a little bit more complex compared to simple indices where you can just look at drought alone or extreme wind. We need to look at it as a compounding event. So in summary, what we note is that under future warmer climate, at least if the mitigation is low, we realize that looking at this drought, there is a likelihood that there could be a shift, especially in the Western Cape area, in terms of the likelihood of drier conditions. And this is just preliminary work. We need to look far into detail into how best can we attribute. There are weaknesses with taking a thermodynamic approach for extreme events. We need to probably think of storyline approach where you can actually run a weather model in a natural environment, and then under analogous circumstances under which such an extreme would have happened under the present circumstance, so that we can check if there are changes in the characteristics of such events. Then we can start to make attribution statements. Otherwise, the statistical approach, there's a lot of debates around their suitability for extremes, and we need to look at their benefits case by case, because each of them would have slightly different benefits that it brings when you attribute with it. Thanks.
Thank you. Really interesting, Mohau. I know with the fire index, there's a challenge with the fuel. I think knowing, whether you're going to get a fire or not will also depend on what you've got on the ground. So we'll move on now to look at ENSO talks. So the first one will be by Teke.
Thank you. I thank you, Neville. I started losing weight. I had to tighten my seatbelt because people are making nice presentation. I was no longer confident of mine. But thank you for helping me lose weight. Okay, so my presentation, I'll try and talk through it. The whole idea is, one, we know that ENSO itself is a very strong signal that determines whether we're going to have dry year or wet year. That's what we know. The other thing that we also know is that each individual ENSO year is actually behaving differently. So the question is, if we have this strong signal that we get, but the outcomes are highly variable, how do we then talk about that? And I'm working with Prof. Landman and Dr. Mateisi. So yes, you have heard from their presentation. One is looking at ENSO and its prediction. The other is looking at attribution. So you can imagine what I have to do. I have to look at ENSO and see if we can attribute any weather systems that exist in Southern Africa and see if they have anything to do with the prediction of our seasonal model. So what we are doing as just an idea and a thought is to say, if we have this signal and you have comparable years, where the signal is strong comparably? And can you attribute that and say the response will also be more or less the same? And what we have found is that is actually not the case at all. So what we are trying to look at is to say, okay, we know our general weather systems. You have the likes of the Angolan low, you have the Botswana high, you have the Indian Ocean high, the Atlantic Ocean high. Can we take all this and create a composite to see how they interact in the absence of the ENSO and see what we can get as the outcome? Obviously, it's going to be mind-cracking, and especially because when you look at the ENSO signal, it's far to the east of us, but based on Southern Africa, we're influenced by the westerly regime of the weather systems. So the question that also pops up is, how does that east signal transfer into a westerly regime of the weather? So that's what we are basically trying to explore. And preliminarily, what we have seen is, for instance, you look at the Angola low and the Botswana high. One, it's fairly stronger climatologically when you look at during the El Nino and during the La Nina, even though when you look during the La Nina, the strength is slightly lower than when you look at the El Nino. So that's what we are trying to ultimately establish and see if we can come up with any link between those. So as the way forward, I'm no longer sure now, because there's been enough presentations that giving you ideas. There's also the machine learning, where I'm also debating, can we just fit all this data into a machine learning algorithm that will pop up with which contributors are main? Because if you look at the extreme weather events, we have seen that these are very critical because they lead to death. So if we can predict seasonally as accurate as we possibly can, hopefully the people from the disaster management and all that can be able to prepare very well, which is currently not the case. And that is in brief what we are hoping to ultimately achieve with this. And thank you.
Thank you, Teke, and he saved us a bit of time. Our next speaker now is going to be Jessica.
Hello, everyone. I'm Jessica Steinkopf. I'm from the Global Change Institute at Wits University. So I'm just going to present some work that Francois Engelbrecht and I have been doing, looking at CMIP6 models and trying to validate ENSO and then look at how it's projected to change in the future. So the validation parts I didn't include because we looked at it over the continent of Africa and there wasn't space. But basically what we did is we took an ensemble of 42 models, and we analyzed how they captured the well-known dry signal in Southern Africa during El Niños with a wet signal over East Africa in an El Niño and the reverse during a La Niña. And then we found over Southern Africa, there was an area thank you. Over Southern Africa, over the Eastern Escarpment, there was an area where when we looked into the future, the models weren't agreeing in what the signal was going to be. So we decided to look a bit more into that, and we took out the models that for the historical period got the signal correct. Okay, so they're models that we knew for the historical period, they showed that dry signal during El Niños and wet signal during La Niñas. And there were 24 out of the 42 models that got that correct over the Eastern Escarpment. And then we looked at what did those models do into the future. So in the top row, you're looking at the crew signal so that you can see what we expect to happen. So that's, you can see in the top left, the dry conditions during El Nino, the wet conditions during La Nina, and then we've got our neutral conditions. And then we've got the full ensemble, so we can see the models do well at getting the dry conditions during an El Nino, wet conditions during a La Nina. They just, they overestimate the impact. And then there's this region of uncertainty. And so if you can scroll down or up, I don't know. What we did is we split. So we took out the models, and you can see here, I've got 11 models that correctly get the signal. They get the signal correct in the past. And what they do is in the future, they project a flipping of the signal over the eastern escarpment. Okay. And 11 models that got the signal correct in the past, those 11 models project a strengthening of the signal in the future. Okay. So it's very interesting. So the model uncertainty is basically coming from some of these models showing that the signal is going to flip and some saying that it's going to strengthen, of the models that got it correct. And if you've been following me and you switched on, I said there were 24 that got it right, and I've said 11 and 11, which adds up to 22. The remaining two signals, the signal was just very weak over the escarpment. Okay. And then what we did very quickly, I don't know how my time is, but we just wanted to see a little bit why. And so we went and looked at the number of extreme rainfall days, the number of days that were above the 90th percentile. And what we find is that in the models that are flipping the signal, they are projecting an increase in the extreme number of days of rainfall, regardless of ENSO signal. So we think that the rainfall becomes so extreme that it's just decoupling from that ENSO signal. Whereas there's not that same projected increase in the models that strengthen the ENSO signal. So anyway, it's a big thing to try and explain in 5 minutes, but I did my best.
Yeah, no, you did. Thank you, Jessica. I think it's an interesting one, and a question that keeps coming up: what's going to happen with ENSO in a changing climate? So we are going to shift basically in terms of topics. So the next two, the last two of the session that we have, these are international speakers, and the topics are going to be a little different from the ones that we've seen now. So our next speaker is Malavili.
Hello, good morning, everyone. Okay, yes, thank you for the introduction. I'm Mala from Malaysia and from Department of Chemistry, Malaysia, affiliated to the Ministry of Science, Technology, Innovation. Okay, yes, it's true. I think when I observe, my topic is going to be slightly different because I'm incorporating chemical innovations for climate resilience, enhancing Malaysian sustainable development. Since I'm coming from that analytical service body, so my main core business will be to develop methods and so on. So if you look at it, my main interest will be on the ozone depleting substances. It's a very crucial substances that it plays very critical role in our climate change in Malaysia. If you can see that, if climate disasters in Malaysia is a simple chart, and the main contributor would be the flood is a significant impact in our country. And the main key challenges in relation to the climate change will be what I've mentioned here, the sea level rise, erratic weather patterns, and so on. Okay, what I'm trying to emphasize here is role of chemistry. Okay, chemistry is very important because for me, that's a very key factor that we needed to come up with some important techniques and so on. So I'm trying to interrelate this with the SDGs, and the main one will be the carbon capture and also with the renewable energy that we are incorporating in many industries. So when I talk about ozone depleting substances, it includes some of the refrigerants that we use in many various industries, also including in our daily activities. And mainly is because I'm sure you all have heard about CFCs and halogens. We use it refrigerants and fire extinguisher and so on. So why is it? It's important because you know that it depletes the ozone layer, and not only that, it increases the UV radiation and the very impactful to our human health, agricultural, as well as the ecosystem itself. Okay, so my reason, as a research part of my research, I made a recent visit to China, and where we were exposed to many activities in relation to what kind of technologies we have. And you know that in terms of detection, we go into our gas chromatography, and then mass spectrometry, and also infrared. And then I think that is what we are currently using to develop these significant methods. And this is actually in line with our national transformation plan, where our main focus is to invest in our R&D and so on. I think compared to other countries, Malaysia's contribution in terms of R&D is very little. I would say is about only 10%. So we wish to increase that, and in that we are seeking some collaborations and strategic partners to go ahead. And our first strategy is now we actually went along with China. and we got some technologies and we have tried to implement in our country as well. And as I said, moving forward is to achieve our net zero gas greenhouse emissions by 2050. And Malaysia hope to achieve that. And not only, and the main thing is by including phasing out ozone depleting substances. And not only that, we are in need for new policies and regulations. We are looking into then adapting on the National Adaptation Plan, revisions to our current Environmental Quality Act to better address the climate change and environmental degradations. I think I've made it clear. Thank you so much for your patience.
Okay, thank you. Really interesting. I think we started making quite a bit of progress since the Kyoto Protocol with the CFCs. So we've got our last speaker. We are exactly on time now. And then we've got a time buffer, which I'll give to Neville to decide how to deal with that. Over to you.
Yeah, thank you. First of all, I'm happy to be here between all of you after 3 days traveling to reach to South Africa. No problema. Who don't have past, he will never live the present. He will never be participant in the future. So because of that, I will explain my organization, the Spark Palestinian Agriculture Relief Committee. It's established 1983, and before the Palestinian authorities came, actually. So of course, we are not controlling the natural resources in Palestine, not controlling land, not controlling the border. So our work with our university, how to keep the farmer free and dependent themselves. So we concentrate in the local seeds, cultural, traditional heritage, local seeds, because the majority of the Palestinian agriculture sector is 90% rain-fed, and 70% of them vegetables. So our project, it was concentrate in how to establish seasonal seed banks locally by running by the farmer themselves with less technology, not complicated, easy to use it. So we make 9 seeds bank in different areas, south, mid and north of West Bank, with 3 nursery, with 6 pilot farm to test these characteristics of these seeds. So the farmer become free because he's not dependent on the big companies to buy the seeds and not buying the chemical pesticides or chemical fertilizer, because they depend in labor, in animal farm. So he have a green green fertilizer and depend in his own seeds. He planted the second season, he can plant it again. So these small seed banks is dependently seasonally. So we create something called saving and the credit seeds bank. So the farmer, he give his seeds, the bank clean it, dry it, and fix it and keep it, and take short like loan benefit to the test, to the pilot farm and to the center. Because if we depend to make one central seed bank, that means it's need a lot of money and complicated technology. And if the fund is stopped, we will lose this bank. So because of that, we go to the field, we go to the farmer to do their own seed bank and to run it with themselves. And actually, because 60% of the West Bank agricultural land, it's not under Palestinian Authority, actually, under Israeli occupation. So the farmer, they are resisting and fighting to protect his land by planting his local seeds, which mean a mitigation with climate change, and he don't need to irrigate it, and he protect his land by using these local seeds. So because of that, we support this project. If you can, no, down, please. This is kind of jars of seed bank to protect it and to put it in good way, easily, cheap, less complicated technology, and they can deal with it. Thank you.
Okay, thank you. We are going to move to our first group session. So I need those group session slides, please, Duncan. Thanks, Mary Jane. So we're going to try this, folks. first of all, you'll notice that there are some color sheets on the wall. That's the one. That's, oh, microphone. Sorry. So you'll see there's some color sheets on the wall. There are people online in the Zoom. We're going to split you into Zoom groups in a minute. There are also some of these color sheets outside. So there's I think that's meant to be red, blue, black, green, and then there's some outside, right? So if you look at your name tag, you'll see that you have a color. What you have to do is match your color, right, with the color on the wall, and that's the group you're assigned to. And we have allocated time now from, where are we now? What is the time? My clock over here. My pocket watch. Okay. 11. Yeah, so we are on time. So we've got an hour to do this. We'll have lunch and then come back and discuss what we have to discuss. So I'm just going to talk a little bit about what we're going to try to do. Firstly, when you get your groups, you can introduce yourselves to each other and select a chair and or a volunteer scribe and or a rapporteur. It's going to be 3 people or the same person or 2 people as you like. So we just want someone who's going to be able to capture the information from the group. Okay, next slide, please. Can I can do this. So what we want to do is get ultimately from all the group exercises cumulatively is a statement of recommendations from this conference. And we're going to present these to the Presidential Climate Commission, who are aware, to DFFE, Lou is now aware, and Department of Science and Innovation in South Africa, and then through the NAM S&T and through SCOPE, through international processes. And of course, the WMO is also here. Hopefully we'll receive this document that we can produce. And what we will do is we will synthesize information we get from these group exercises into a document. And we're going to get each group to consider the same set of questions, and then we'll hear from plenary from 1 or 2 of the groups and see if we can build a picture from that or a consensus from that. And whatever resulting document we do have, we will also include in the special issue of environmental development. I can change the next slide. So, oops. Okay, so just check. Yeah. So that's what we want to do with this. Now, before we set you off, you've got a sense of some of what is going on, a lot of it obviously in South Africa, of the work that is being done. And so what we really want you to think about is what is not necessarily new, because as we say, there's a lot that's ongoing and a lot that we haven't heard about that is ongoing. But what we want to try to do is iterate this in a consolidated way with a focus on extreme events in particular, as opposed to broader applications of climate science or other climate research. And so what we want to do is, again, sort of antithetical to the idea of integration, is to disaggregate the thinking, to identify in the components of an integrated approach what it is that we need to be doing, both in terms of process as well as content. So not only content, but also process. So notionally for this meeting, we've split it up into these 4 different elements. Those 4 elements over here, they obviously are all integrated. They all overlap, as you've heard in some of the presentations. They're very connected to each other. And so they're interrelated and interacting. So disaggregating them is not very helpful, but we do need to think about the sort of disciplinary depth that goes into these different components. And of course, the utility is broader than just extreme events. Next slide is here. So what we're providing you with is discussion tinder. No, not that tinder. Somebody was asking me, what are you talking about? Tinder, for those that don't know English well enough, has an original meaning. Anyway, be that as it may. So for this exercise, what we want to do is get you into groups and get you to, as guiding questions, and I stress this, these are guiding just to get the conversation going. the kinds of things we'd like you to come up with in each group is one or two, and I'll leave this slide up, one or two bullet points that we can integrate at the end to answer these questions. What processes would you recommend or adapt that already exist, for example, to organize, in this case, we're talking about the climate science, the climate research and the production of scientific evidence and information for extreme climate events. So the kind of what should be done, what should we be producing? How do we organize this? Who should be involved? How should it be done? So that's the kind of question we want to ask. And then, so that's more about process. In order for us to come up with a way in which we can make sure that the research is the climate science aspects of the research is addressed. And then potentially there are some questions about key research priorities and associated glaring gaps. We've heard about some this morning, glaring gaps that require investment and special attention. Just those two questions should be enough to get the conversation going and for you to draw out in the next hour some information and thoughts from delegates. So please be brave, enjoy it, please be participatory, please be bold and volunteer your help to your group. And let's see what comes out of this conversation. Just for your information, we're doing the same thing in the second session, which we will do on observations. So we'll discuss the same type of questions about process and content in getting organized about observations. We'll do the same about risk and vulnerability and how we assess that to extreme events in particular. And then finally, we'll look at questions around implementation and action. And so we're trying to cover the sort of broad value chain through this process. But for this exercise, for the next hour until lunchtime, and I'll signal to you when time is up, you'll hear the trumpet blow. Just trying to address these questions as your starting point with the real goal of coming up with some recommendations about what we really need to be thinking about for the climate science in this aspect. So that's what we want to try and do with a group, okay? So next thing I'm going to ask is that you look at your color and then find your spot, and then somebody's going to take the lead in each group. It's a good social experiment to see who's going to be assertive enough. All right, so let's do that now. Thanks. Please move on to your sections. Thank you. They should be serving us, I don't know, Red Bulls or something instead of heavy food. But anyway, there it is. So stay awake, stay awake. Okay, so this afternoon, so again, remember this is a fairly experimental format that we are trying. So we've had the whole series of flash talks and keynotes, and then what we wanted to do was to give you an opportunity to kind of start conversation, and we gave you some conversation starters, and we had asked that you try to focus the conversation on the climate science aspects. Of course, you didn't do that, did you? So clearly the conversation, as I picked it up around the room, was quite broad and integrated, and I suppose that's just as well. But it does mean that when we have further group discussions tomorrow, I think we've got 2 scheduled for tomorrow, that the conversation in an integrated way will continue tomorrow. But I want to stress this information that you are generating and the thoughts that we've got that are coming out of this conversation is really important as an output of this conference. So this information is critical to us, not just the inputs that we are receiving. So the scribes and the rapporteurs, if you are different, one of the 2 of you in each group must email that to me. So you have to write it up in note form and email it to me. And we will collate this information and try and aggregate it and disaggregate it and work through it and try and find the common threads and so on into a document. But we do need that data, that material, because otherwise we're going to be making it up on your behalf. But we do want to be true to the conference and try and capture all the ideas and the debate. So it's really important that you email that to me, and I think you've all got my email address that need it. If you don't, please ask. But for the report back, we're not going to listen to every group now. We're going to listen to some of the groups. Can we go up one slide? Next one. Yeah. Okay, one more slide. So one more. So this is kind of what we provided as fodder for the conversation. So let's see if there's any one group that wants to present, and then we'll see if other groups had a very different conversation, and we'll get another input from another group. And then we'll see how much time we've got and what other contributions we can get in this plenary. So is there any particular group that wants to go first, or should I just pick a color? Going. I'll tell you what, if no one's going to volunteer to go first, come on, somebody's keen. I know they're keen, they're just shy. Okay, good. Thank you. Please come. First of all, identify your group color. And then introduce yourself, and then go ahead.
Thank you so much. Hope everyone had a good lunch. I am here on behalf of the Blue Group. And my name is Claudia Schroeder from ICLEI Africa. I'm sure similar to many of your groups, we had a very diverse range of participants within our group, and it made for very interesting conversations, and sometimes we did veer a little bit off topic. So yes, I'm going to just highlight the key outcomes of our discussions. So the first point that we were required to discuss focused on the processes that we would recommend to organize the climate research and the production of science evidence and information. Of course, we ended up having more questions than answers to this, but rather what we had was maybe some key recommendations to consider when developing a process. And the first point that we kind of discussed was the need to understand the end user when it comes to climate data in its various shapes and forms. So who's going to use that data and for what? Then we really delved into the concept of accessibility to data and the need for a centralized repository or enhanced coordination when it comes to accessing climate data in its various forms. And this basically led us to a rabbit hole and unpacking concepts such as, reliability of data, trust, given that, when it comes to climate change, it's a cross-cutting concept and various type of expertise. So not everyone necessarily works with the same language. And that kind of led us to the important and very much topical concept of communication, which one of the presenters even highlighted earlier, and the role that language and terminology plays in this space of accessibility. And then in terms of the centralized repository that I mentioned, again, under accessibility to climate information, we, of course, unpacked that even further and highlighted the importance of, improving stakeholder engagements, again, highlighting coordination, so possibly having a go-to place to access information or certain bodies to access information when it comes to climate data, and even the possible role that guidelines can play for integrating, so frameworks or guidelines within certain departments. And then delving into the second aspect, what are the key research priorities and critical associated gaps that are required investment and special attention? So I'm just going to highlight some of the key aspects that we mentioned. So the first one is adaptive management. The second one is MRV, or monitoring research and valuation systems, the importance that they can play in access or integrating climate data, but also just, I think, cross-cuttingly. The need to update guidelines and frameworks for decision-making, investments in technology, funding mechanisms. So for example, what funding mechanisms are available to researchers, to companies, and those exploring various extreme climate event models or research components. And then, of course, another area that we mentioned would benefit from some additional research is the role that AI can play in the climate space, particularly in terms of integration. Yeah, so that's just a little bit of a snippet. I will be sending the notes to you. So if anyone wants to see more, thanks.
Thanks. So nothing about climate science then, huh? Thanks. So again, I mean, we did try to think about this in a sort of disaggregated way, but given the fact that there's a wide variety of interests and stakeholders in the room, it's inevitable that the conversation is broader than any one of these topics. So that's useful for us. And again, it's a way which we will use both to aggregate the thinking as well as to disaggregate it into the various components. So thank you for that. I want to ask, are there any of the groups that dealt with some of the specifics around climate science that they might want to offer us other than the integrated approach? No. Yes. Please.
Hi, I'm from the Purple Group. I think we had two specifics on the climate science. The one was on better understanding the method for producing high resolution models and what the different trade-offs are, so that we know what high resolution stuff is the best to use and that we have faith in that. And so using different methods, looking at satellite data versus simulations versus other options. And then there was also, I mean, we spoke a lot about the knowing-doing gap, and the issue of scientists needing to understand how their models are being used and the implications of that, because I think that would make people present their caveats slightly differently, and really trying to understand what the limitations of your models are before you put it out into the world could be quite helpful. Yeah, I mean, we've got a lot of other points, but that was specifically to the science.
So that's the Purple Group's going to talk more now. But I just want to say that what you've reminded me of is this idea. So the idea that you presented now, Claudia, about the idea that the climate science needs to be calibrated so that its outputs suit the ultimate users. And so that opens the whole conversation of kind of, what is data, what is information, and so on and so forth. And that's not a new conversation, but why I'm highlighting this, and you kind of reminded me of this, because you said a similar thing, is that it's all very well have model will travel is no good. We've got to have the application and the user and all that defined, which does not undermine the need for model development in and of itself as a discipline, I need to add. But why I'm saying all of this is just to come back to the National Framework for Climate Services, or the Framework for Climate Services, which is such a simple but yet intuitive model, which covers this thinking, which is to say, you've got a user interface platform in which the conversation between the various producers of information and users of information happen, and then it sort of works back up the chain to define the modeling, for example. So that framework is there to be populated. But let's go back to the Purple Group for more. Are you it? Are you it? I assume you are.
Thanks. Can I stay here or must I come to the front? My computer's dying, so it's down here. Yeah, so we had quite a lot of practitioners in our group and not many climate scientists. So we focused really on how the information needs to get to people. And there were kind of two groups of people. There were those who wanted to use the direct climate data for further research. And then there were those that are maybe slightly further removed and really trying to do applied research. And there were distinctions in the type of platforms that needed to be available for these different groups. So, for example, there's this whole integration of models and tools, and we spoke about things like having a platform. We had someone from the National Defence Force, and he was saying you need to have a platform that you can go to and be able to find what are the predictions that will impact on national security. And I thought that was really interesting because it's very different from the person who needs to go there to understand what's going to happen to pregnant women, or some of the other examples from the talks that we had this morning. So there was this integration of tools, and then it also had to fit to people's mandates. So there was a discussion of, oh, we need this thing, but actually there's a lot of existing stuff. So which of the existing platforms do we fund and really mobilize. So we spoke about the mandate of the Department of Fisheries, Forestry and Environment and of SAWS. And then there's this national framework that you're talking about. But I think if one was clever about it, you could leverage something like GCF funding to actually get this whole platform up and going because of the downstream effects that one could have to all of your users in different sectors. We spoke a lot about open source data and the reason that open source didn't happen because each department and agency is trying to leverage their own funding from what they have available. And how does one break down that a barrier? That is a massive barrier, be it a university institution, be it a state-owned organization that doesn't necessarily want to go the route of open access data. And then there was a kind of need for a platform of people. So all the different practitioners that can get together, it's more than just the data that needs to be explained in a really useful way. It's also how do the people find each other and ask the right questions to the right people. And then just for the scientists, how can we ensure that the information is more widely known? So increasing public awareness, and there's a huge need for science communication. Then in terms of the gaps, I've already mentioned two of them, the high resolution models and understanding how models are being used. Then there was this whole need of research to understand national security and what is happening at our country level and beyond. There was a gap in the transport sector, which is focusing very largely on mitigation, but how do they actually need to adapt? And we talked a lot about the consequences of going green and who's doing a life cycle assessment of green tools that are being proposed, looking from cradle to grave to assess the true costs of the green energy options that are being put forward. And then who is researching the unintended consequences of climate change adaptation. So we had some interesting social examples. So if you take away the need to walk to a stream for water, you're taking away an important social discussion opportunity from the people that partook in that activity, and also potentially some of their practices and beliefs. So yeah, unintended consequences in general, more broadly. Group, have I done okay?
Thanks. Yeah, there's a lot. We can go in all sorts of directions from here, I think. I just want to reflect on a few as chair, and that is, so there's a monster in the room which eats the elephants in the room, and that's which we're not going to talk about, which is the whole data question. Whose data? How do we access the data? What do we do with the data? That's an old story. We know that's a challenge for all of us, and it's not just source data that we're talking about. It's all kinds of data which is proprietary in one way or another, difficult to get and difficult to manage. But again, there's envisaged in the climate, in the climate services, the framework for climate services, this portal, this thing, which is a kind of a big dashboard, public-facing dashboard, which is something, which we all, I think, have a vision for. So that's really important. And then another thing that struck me while you were talking was about, and I mentioned it this morning, is about scales. So what models are used at what scale? And, I'm just thinking about the malaria project that I was involved with Willem, where we had 3 models all doing different things at different time and space scales, which kind of nested among each other, or they had a relationship. So one might have been a seasonal scale model. One might have been or seasonal outlook model. One might have, and then one might be a very district-focused kind of operational model for the next couple of days or weeks. And so we're looking at different kinds of models to be used at different timescales. So what becomes important is not just the space scales, the high resolution, I think is what prompted me. Obviously, we need high resolution in the event of an event, of an extreme event. We want to know what's going to happen. I'm just going to use an example of this. When we spoke with people in a sort of post-mortem of, excuse the pun, of the Durban event, the guy from the Housing Development Agency, his question was, where can I move people to now, which is safe? Not in an hour's time or in tomorrow, but now. And the kind of information that they need is really to the minute. And you're all familiar with this kind of sliding scale. So the high resolution, this kind of static standing information which goes into that, but the dynamic aspects of that really are critical. So I think time and space scales and the kind of approach to the climate science to cater for that full range is necessary. Okay, that's enough editorializing. Before I ask for anything very different, I would like to just check again from a more climate sciencey, science point of view. Are there any other inputs around the science? Please, good.
Thank you. I'm going to remain seated so I can read here. So we are the yellow group. I thought the yellow, but it turned out orange. So maybe I am colorblind after 50 years of my life. I'm not going to cover everything we said. I just want to add around the first question on processes and adaptation. We made the note around perverse incentives and maladaptation. There are human behaviors that game opportunities around disasters. So an announcement of a drought at a certain level triggers a certain government response with financial aid to farmers, and that does change farmers' behavior around however they acquire equipment and how they run their. So there is the other example was, I remember from in Cape Town, can't see where you're sitting, when the warning came out of high seas, people actually booked at Kalk Bay restaurant to go and see what the high seas look like. So that's a sort of perverse incentivization and maladaptation. To come to your actual question around science, we felt the short-term forecast for disaster response is probably quite mature. It's something that is happening reasonably well. There's questions about how does information get to whom, how people perceive the information, how they respond to it, and that's a package. But then we spent quite a lot of time on the improvement of medium-term and seasonal forecasts. With Willem there, it was useful to understand that model improvement is typically, so far, has happened in areas of high predictability. The model improvement doesn't necessarily happen in areas where models historically have had low performance. So the better areas get better. The bits that get wet, we understand even better, but it's not as if there's a uniform understanding of wet and dryness. We've got a better understanding of the wetness and where the models improve is in the areas which we already know they're doing quite well. So that's a science gap. Willem, did I summarize that right? Then we talked a lot about the observation network needed. Really interesting, the disaster cost of the numbers that came out. The KZN losses around impact and loss of productivity, 100 billion rand. But if you think about the slow loss, the silent loss of long-term drought, that becomes a significant portion of GDP. So making the case for better observational networks, better maintenance and expansion of observational networks to avoid the 300, 400 billion rand loss in the agricultural industry shouldn't be difficult to make, but yet that is not happening. So there's something about the cost, the value proposition, and the return on investment that is not very well understood. We talked about how to leverage AI opportunities with fundamental mechanistic understanding and seasonal forecasting. Didn't come up with a solution, but quite a bit of discussion. And then we also talked about attribution research, operational attribution research for Africa, recognizing natural variability in certainly Southern African environments, maybe other subtropical latitudes as well, makes attribution more difficult. So that means the need for seasonal forecasting and the skill for attribution is even more important. And the long-term risk here is that if we're not good enough at attribution, we might miss out on global loss and damage initiatives. Thank you very much. Anyone from the group to add just on the sciencey side? Thank you.
So just one thought I want to throw into the conversation is the kind of extreme event we're talking about is really important in the kind of information, the kind of communication. It seems obvious to say. But, you know, a sexy fire or a flood, you know, we can issue a warning and go to high ground or whatever, don't have a braai. That's one thing. But a drought, which is something insidious that it's taking time to establish, you know, that is not, if you like, a short, sharp event, is much harder to manage, I would imagine, in a climate science. I mean, the predictability of a drier season is one thing. But the event itself, the manifestation, is another. And so again, we have to think of scales, time and space scales, to think about how to do this. Attribution has come up there, which I think is, again, obviously very important. I keep wondering about the utility of attribution and why we need it. Is it so that we can loss and damage claim? Is that the reason? Or is there another reason? I'm interested to know. Guy has his hand up, but then there's a microphone right next to you there. Then I want to see other groups' inputs as well. And I see Jessica's hand.
So important for our policymakers because they negotiate in the UNFCCC about the rules, about the way that attribution is used. And if we feel that much of Southern Africa and much of the subtropics is going to be a disadvantage from accessing loss and damage financing, then we shouldn't be negotiating, we shouldn't be supporting scientific attribution as a way of doing things. In other words, we could be negotiating ourselves into a dead end, and we want to avoid that. So this is a very real risk. If we cannot attribute, and we don't have the mechanism to attribute, we don't have the data sets, we don't understand the long-term, the seasonal forecasting, we should be trying to work against that particular outcome.
You know what you're saying? You're saying that if we agree that attribution is the mechanism to acquire loss and damage compensation, and we can't attribute, then we're putting ourselves in a trap. That's your point.
Agree to that. So our negotiators should withstand that, because the better parts of the world are going to get all the money. The guys with all the data, with all the attribution models, with all the skill are going to get the money. We're not going to get anything, which is typical what happens to Africa.
I see Bruce has got his hand up, but there was another hand. Jessica, do you want him? Okay, because it's on this point, I take it, right? Okay, so then I'm coming to you afterwards. Thanks, Jessica.
I'll keep it short, don't walk away. I think there's a clear scientific value to attribution is in order to understand the role of natural variability.
Thank you. Okay, Jessica, you were going to say something similar by the look of it. Okay, I see.
So from the yellow group, the real yellow group. From a science, so just on attribution, so it also came up in our discussion in terms of the need to like look at attribution and better quantify events in terms of climate change. And the discussion then led to natural variability. So we need to better know, because extreme events by nature are very rare. So it's quite difficult to understand the natural variability of those events to then attribute them to climate change. So that is a field that definitely came up in our discussion about that. So that was just, okay, I won't go into we had a lot of other discussions. Do you want me to? Okay. Okay. So there was also a lot of discussion around a research gap in understanding model uncertainty. There is research needed to understand what the gaps actually are in research. Linked to the attribution work and understanding natural variability in extreme events, I think the group felt there was a need to really understand the dynamics behind why we see the changes that we see. So really researching those dynamics into what's driving those extreme events and the changes in those extreme events. A need to better understand compound events within the context of extreme events. And okay, so that's must I just do the sciencey part? Oh yeah. Okay. So more towards your question one, there was a lot of discussion around facilitating collaboration, facilitating transdisciplinary work, and it should be about facilitating coordination. So not organizing it, but facilitating the coordination of it. So the idea behind that was to develop a community of practice. So you create communities of peers who then get to know each other and they work from the beginning together. It's not an end user driven process. And I think I think I've got everything. There was also the discussion around terminologies and a misalignment between fields in terms of terminologies and the importance of language across the different fields. The definition of extremes is also different across disciplines and fields, so that's important. Misalignment of timelines in research versus what's happening in practice. So yeah. Would anyone from the yellow group like to add?
Engage with again. So this is very rich and very helpful. How we sort through this information is going to be more of a challenge, but I just want to pick on a few things. Also, something Barnes group said as well. So where models work, they are improving, and where models don't work, they're not improving. And I'm going to caricature it by saying that, you know, if you're working on seasonal forecasting in Limpopo, you're golden. If you're looking to work out what kind of winter we're going to have in the Western Cape, is it going to be a wet one or a dry one? You're in trouble, right? So nobody goes there. And I've always thought, like, you know, do we go back to first principles on this? And we've actually got new tools now. We have got new tools. And I know people are looking at AI and machine learning kind of approaches, try and figure out, you know, put in the black box and see if it comes out with a prediction that has skill. But indeed, you know, given the experience we had in Cape Town, for those who are not from Cape Town, who don't remember, you know, in 2018, we dried up in February. And there was potentially a massive crisis. And I think, was it you, Willem, who said that the farmers did dry up, or somebody said it, right? Guy said the farmers did dry up. So I think that's important. Model uncertainty, well, I mean, maybe Bruce, you can help me understand the difference between the incongruence between models, among models, versus model uncertainty, which I suppose is within models, and how that's dealt with. And I mean, we have spoken about that today. I just hope I'm not misinterpreting you. And found that the magic bullet is the multi-model ensemble, right? We just put them all. I'm kidding. Just trying to piss you off. And then, so I wrote something I can't read here. So I think it says attribution. So, I mean, a lot of conversation about the attribution clearly. And then the trends, indeed the trends. And here I want to throw in the complexity of how we measure trends, whether we measure them as climate parameter trends, or whether we measure them, and this comes to the definition of extreme events, we measure them in terms of damage. Lives lost, infrastructure lost, costs, etc., because of course, what's in harm's way is also trending, and so to disentangle those becomes a very important element of definition. I think that's a really critical aspect. And then compound events are also fascinating, because the storm surge that I think who spoke about the storm surge just now, the storm surge event is a classic example. Well, it's a compound event in the sense that there are compound drivers that are confluence. There's a confluence of compound drivers, which results in an event. But the classic hurricane, which is got a storm surge and destructive wind and flooding, are also really important. Bruce, do you want to just correct me?
I'd never dare correct you, Neville. No, I mean, uncertainty, you're talking about the scientific uncertainty of your outputs. The non-congruency is the fact that different data streams are equiprobable, but they disagree. So how do you work with equiprobable but differences as opposed to uncertainty within, which is the sort of scientific? Yeah. So.
All right, good. All right, so now we've heard a bit from some of the groups. Let me hear if there are other groups that had very different conversations, which are equally valid, please, which may not have directly spoken about the science, or some really important ideas that may have emerged from some of the other conversations that can add to these. Please be bold. Ross?
Sorry, it's only going to be 1 point. So this is from Team Red with the gaps. It's the training and education about data for non-climate scientists. there needs to be a forum in place where there's data, like if you're using data, you don't use it blindly. There's some sort of trust behind it. And so one of the discussions was, well, how do we go about that? And I think it's one of the research gaps that we sort of have to cross is with data. I mean, I think every group probably spoke about data in the first question, but the second question was, okay, well, how do we do the training and the research for non-climate scientists?
I've got to turn that on its head as well. How do you do the training of the scientists about the non-climate contexts?
Liwe wants to add, please. Yeah.
So this was from the Green Group, and most of the things that we have discussed have been mentioned. But what we also discussed is that the social impact on data collection and data presentation has been lacking. And it answers the why question of why are we collecting this data and why are we doing this research? And that part of the social impact can look at the vulnerabilities and the impacts that communities are facing from these extreme events so that they understand what is going on in their communities, and they can use their indigenous knowledge to adapt because they know their social constructs better than the people. Also, I mean, the people in the science community. Also, the importance of coupling the top-down approach and bottom-up approach in the research and the data collection. We need a two-way system where climate scientists can inform the public about what's going on. And also we need the communities who can share their knowledge, expertise in their social contracts about how they see these extreme events playing out in their communities. So that's what we discussed.
Application side, and we're going to deal with more of that a bit later in the conference. But as I say, this is a kind of integrated thinking, and also reminds me of the idea of various programs and projects that are and have mapped vulnerabilities. But we're going to have more conversation about that later. Okay. Yes. Okay. Oh, there's somebody online who wants to speak. That's great. Sorry, online, I forgot about you.
Yeah, I think there's just one point, please. Pink team, let me know if there's anything else that's relevant to the specific discussion that I've missed. I think the one thing is also to understand the fundamental limits to predictability and to do research to try and understand which questions can we answer, which questions are we never likely to be able to answer, so that people who are further along the chain of impacts and implementation can prepare for not ever probably being able to get certain types of information out of climate science. So to try and understand what are the fundamental limits to predictability from the tools that we have in the climate science toolbox.
Thank you, that's useful. Before we go to the online person, I just want to leave this idea with you because this is what you reminded me of, which is if we characterize extreme events trends in 4 ways. One is the frequency of the extreme events. The second is the magnitude. So how big an event is it? The third is the duration of the event, how long it lasts for. And the fourth is the seasonality of it. So something which might be within annual variability range, but out of season can be regarded as an extreme for that time. So in those 4 terms, where are we lacking, or where do we need to focus our science? And there might be another parameter of extreme events that we need to consider. But what I'm not hearing is that, fundamentally, it seems to me that in terms of predicting, at least in the short term, short time scales, the event's occurrence, numerical sort of weather scale forecasting, we're okay. I'm not so sure about the magnitude. Yes, it's going to be pretty windy today. It's going to be cold. There's cold snaps. Move your goats inside, and those kinds of warnings that we get. Expect flooding and so on and so forth. So I suppose that in a sense is a magnitude. Duration, that's also kind of weather forecast, and then a seasonality. And these trends, what I'm wanting to know from you is, where is the science emphasis? Where does it need to be? But let's take the online question, and then I'm going to come back to the floor. Go ahead, online person. Please identify yourself.
I assume you're talking about me. Can you see me?
It's
Or can you
Debbie
hear me
Muir.
at least?
Yes.
Debbie Muir, yes. I'm from the Department of Forestry,
Can you
Fisheries
speak,
and
Debbie?
Environment. I'm speaking. Can you hear
Can't
me?
hear you. Is that us or them?
Well, I'm not muted. Let me do this. Can you hear me now? Can you hear me?
We're going to see if we can hear Debbie Muir. Otherwise, Debbie, you're going to have to phone me.
Because I'm unmuted.
I can hear you.
No.
You can hear
Okay.
me.
We can't hear you, Debbie.
Only the
Perhaps
people
you
online can hear you.
write
the
something in the
people
chat
online
and
can
we
hear
can
me.
read it out.
Online we
But
can hear
that
you.
just reminds me to say that the online thoughts, contributions, and ideas are equally valid, and we would like to keep
Okay,
those
so
in
would
the
the
record.
online people like to hear what I have to say, or
She
can
has
or can
written,
you just read it in the chat box?
you'll have to go down, that way so I can read a bit more. So you bring the text down to, you got a delay, sorry. So Mark has said something, there it is. My whiteboard disappeared, but Group 2 online looked at the link of pesticides and chemicals as a pivot in the climate smart approaches across broad categories, and the reduction of highly hazardous pesticides and chemicals will reduce the potential increase in climate change due to temperature increases that can potentially reducing the use of IIPs and chemicals. This also links to agriculture through the contribution of greenhouse gas emissions from family practices. I'm reading farming practices. Sorry, I'm too close here. Suggest cleaner and stronger regulation to something, climate change
Enforce.
mitigation. Oh, you're there.
Can you hear me?
Yes.
Oh, I'm
Now
so
we
glad.
can. Please
Okay, right.
proceed.
Okay, I'm so
Put me out of
glad.
my misery.
I'm so glad. Okay. What Group 2 discussed is basically the potential to go back to the drawing board, jokes with the whiteboard, to look at your indicators that are pivotal to everything that we do, which is pesticides and chemicals. Now, pesticides and chemicals are used in broad categories. Now, I'm talking from industrial to forestry to conservation to agriculture, across the board. Now, what we looked at is, if you're looking at that and you're looking at the climate smart approaches in climate smart agriculture, forestry, conservation areas, etc., there is a huge proportion of indication that if you reduce the use of highly hazardous pesticides and highly hazardous chemicals, it will reduce the potential impact on climate change by reducing the potential increase in temperature. Okay, so that's what I was trying to say there. And this also then links to the cunning Montreal Biodiversity Framework's Global Biodiversity Plan under targets 6, 7, and 8, but it also links to the Paris Agreement under the UNFCCC. So what that basically means is that if we can get, say, just South Africa, or even just one province, to reduce substitute and eliminate using precautionary measures in the hierarchy of control all the highly hazardous chemicals and pesticides they use and substitute with safer alternatives and biopesticides, it will reduce the impact of the temperature increase, which will be compounding towards the Paris Agreement target. And so I'm suggesting that the impacts of pesticides and chemicals on climate change should actually get a little bit more attention than it currently does, because that is a pivot of a huge economy that it can impact. And then also the impact is seen as increasing. There's been research currently published to state that pesticides, highly hazardous pesticides and highly hazardous chemicals can contribute 0.7% temperature increase towards climate change. So there's a huge drive in the conservation, agriculture, forestry industries to reduce their use to try and bring down their impact on climate change.
Thank you. Thank you, Debbie. I think I'm just going to ask the audience whether on this particular conversation, this particular group exercise, there's anyone who has something they think that should be enunciated here in this plenary on the science or related to other things you discussed. Or if you feel like you've covered it, Guy has his hand up. Other than Guy, anyone else going for the last time? Are we going to move ahead in the program? Okay, Guy.
Just one point that the huge gap is obvious is understanding decadal variability, and we focus a lot on ENSO, but there are other IOD, the SAM, other things. But our focus on long-term climate predictions and projection in the global modeling fraternity has diminished effort in understanding variability to some extent, or maybe to a large extent, I don't know. But that's a big gap for the subtropics. It's a big gap for Africa. It's a big gap for us. And we need to persuade the international community to invest money in understanding decadal variability. It's going to be better for us.
So, Stephanie.
Thank you. I'd like to add to your list of four a fifth one, and that is extremes that are shifting across into areas where they haven't been occurring before, new extremes, which is already starting to happen in some cases in
the spatial distribution of extremes.
Spatial areas that are not used to having very, very strong winds. So areas that have always had strong winds are probably quite well adapted to it. But areas where that hasn't been a problem, it's becoming a problem. Those are the areas we also need to focus on.
Thank you. I had a thought which has now just escaped me. Guy, your point was about decadal variability. What I wanted to say was one thing I think that I'm kind of digesting is this idea of scale. And on time scales, obviously we're talking about the weather time scale for extreme events, and we're looking at seasons, what kind of seasons we're looking at, decadal scale, variability and predictability, and all of that. There's another scale, Willem, which Willem is very focused, and some of his students are focused on, which is what's called the seasonal to sub-seasonal scale, which from an operational point of view is really important because it's between the season and the weather forecast. And that's also critical in a really weak area of climate science in predicting the likelihood of extremes. And there is some skill developing in that area. Do you want to add anything to that, Willem?
The skill is mostly associated with a typical weather timescale of 14 days, and nothing much to be seen for weeks 3 and 4. And also much better skill for temperature predictions than for rainfall. Rainfall predictions are really disappointing.
So why that's important is because if you're talking about early warning, it's one thing to give a day's notice or 3 days notice. It's another to give a week or 2 weeks notice, for example. Okay, but I don't want to drag this out too long, even though we did allocate a bit more time to this. So Jon, we're going to proceed with our program, barring any more final comments. So thank you all very much for your thoughts. Please, will the scribes and or rapporteurs make sure that they deliver that information to us so we can use it. And there will be other opportunities for further conversation. So we're going to move ahead, slightly ahead of schedule now, so we can maybe finish the program today a bit earlier. And so Jon has kindly agreed to chair this session. Jon, here is your list of victims. Sorry, it's on this page over here. Okay, there you go. And
thank you. Was something I forgot to mention yesterday when I gave the talk, and that is 2 of my colleagues in Norway are actually graduates from Stellenbosch University. So, and they are very nice people, and I like them very much. So, yeah. So let's proceed then with the program. And it's my pleasure to introduce John Harding, and he is going to talk about improving observations and early warning service delivery, a development partner's perspective. Please.
Thank you, and good afternoon to all of you. And let me start by thanking Neville. Let me start by thanking you, Neville, and Guy and your colleagues and the partners for bringing us here for these days. It's so far, I mean, the presentations have been excellent. The discussions have been really valuable, and we really see the value of bringing in people from different disciplines, but also from different countries, and I know it's really appreciated. A little bit of a shift here in focus for this session. I have a confession. I'm not a climate scientist. I come from the World Meteorological Organization, and I'm not a meteorologist. And actually, I don't even have a PhD. So before you start walking away, I do have some experience. I come from a development assistance background. I've mainly been working in and traveling with the UN, with a few years in the World Bank. So it's been over 25 years of experience there. And most recently, I'm working now at the World Meteorological Organization on an initiative that's called CRUISE, Climate Risk Early Warning Systems, which is a dedicated new financing mechanism which is available for least developed countries and small island states to build up their capacity when it comes to a lot of the things we've been discussing this morning. Let me see if this works. Great. So I'm going to be talking a little bit. If we want to achieve the objective of this workshop of really building the resilience and the capacity to extreme events, we're going to have the effective financing mechanisms and effective development cooperation structures to actually help countries build up their capacities in this regard. And this is one of the priorities of the World Meteorological Organization. So obviously it's a membership-based organization, and there's few areas that I've worked in where the capacity gap between some of the more advanced countries when it comes to national meteorological agencies, disaster management agencies, is so wide with regard to some of the countries with very limited capacity in this area. So really one of the priorities is to bridge that capacity gap. And these are some of the things that sort of keep us awake at night when it comes to thinking about how can we more effectively achieve that. Obviously, it's going to require financing. When I talk about financing here, it's not national financing, public funded funding. It's overseas development assistance that I'm talking about. And of course, we can always influence where their priorities are from our funding partners, and that's something we spend quite a lot of time doing. But also, we have to understand where the pockets of money are within the ODA system and align them as best you can with the kind of topics that we're talking about in this event. We need much more robust methodologies for assessing the country's gaps and priorities across timeframes, across sectors, across hazards. And we also need then what I call fit for purpose. So Bruce, I've used 2 of your terms here in my first slide, now robust and fit for purpose. for programming frameworks. So what are the modalities for which we can actually support these countries more effectively? And then we need to be able to show results, understand what does success look like and how do we show results. And this is basically a bit the outline of my short presentation here. I think I have one slide for each of these, and I'll finish with a slide which shows basically what are the modalities that we currently have available for financing this work. And the next slide, please. So if you look at the sources of ODA for observations and early warning services, there's a very long history of development assistance in this area of work. Organizations like the World Bank already have a 1.5 billion portfolio of projects on this topic. It's not always had a very the impact, the success that we'd have liked to have. The effectiveness of this financing hasn't always been as high as we would like to see it. Some of the biggest, but it's always had a very strong emphasis on infrastructure, but also on some research cooperation. Some of the big changes have occurred in recent years, in particular in the context of the climate change discussions. So in Paris, the early warning systems was recognized as a priority for adaptation, and this opened a lot of gates for financing in this area. So we've heard quite a lot about mechanisms like the Green Climate Fund and some of the other financing mechanisms related to climate change started prioritizing this topic, which is good, even if it's quite slower than we'd like it to be. And it also initiated, for example, this establishment of the specific financing mechanism that I currently head, which is CRUISE. More recently, there's been more emphasis in the climate change discussions on global climate observation systems and the importance of these kind of structures. And so at the COP 2 years, was it 3 years ago, where there was the launch of the Systematic Observation Financing Facility, which is a dedicated financing facility for observation networks, which recognize observation networks as a global public good. And so that it requires financing, global financing for the weather stations across the world. And it was also, and here it's important, the launch of this Early Warning for All initiative, which was launched by the UN Secretary General. And my colleague, Johan Stander, who's the Director of Services, will be talking more about that tomorrow. Of course, some of the funding also is linked to humanitarian funds. And we already, I think there's a number of discussions too. We're seeing this emerging area of potential financing related to loss and damage, which hopefully won't be driven by attribution. But the modalities for that financing is still under discussion. So before we actually see the taps opened on that one, it's going to be a little bit of time, hopefully not too long, but it can potentially become a very important source of financing for our work. We can have the next slide, please. Okay, I just left this slide because this is typically the kind of slide when I tell my colleagues I'm going to go to a meeting in South Africa that they prepare for me. And I always find it's like as if I'm going to come here and tell you, that you're really impacted by climate change, and so on. So I basically kept it to show the kind of information that we need to be able to generate if we're going to trigger additional financing for this work. So we need to have a strong understanding of the current impact of events, and particularly on development and the scale. We need to be able to show the cost return of the potential investments in this area, which again I heard from Bruce is a global north approach to this agenda, but it is an agenda which in this case is driven by donors. But then you also need to understand what is the overall scale of the financing required to address this issue. And so this is the type of information that we're continuously looking to generate for across our different either regional or country programs. So currently we're trying to get a lot better at more systematically assessing where the needs and the gaps are when it comes to both observations and early warning systems. So as I said, it can be across the different timescales of the climate predictions or weather services, but also across different types of hazards. WMO has a very effective strategic handbook to assist their members to assess this. And we typically take an Earth system approach, so across different disciplines and services, and that's a very useful tool to do that. But we also have to look across the elements of the value chain of an early warning system. And as you know, depending on which institution you're going to talk to in any given context, you're going to get a very different view of what those priorities are in any given country. So we're trying to develop more integrated tools. We have what you call the multi-hazard early warning system checklist, but we also need these mechanisms within countries to bring together these relevant national entities and partners, so we can have a multi-stakeholder view of where the priorities are at a national level. So this is the kind of information that we generate. So we look at the capacity. This is for the SADC countries, and you can see we assess the status of the different of the national institutions. In this case, it's the national meteorological agencies and the hydrological agencies. So this is something which we're getting better at. We still, for example, we still don't have a very common understanding of what basic capacity, or I mean, here we used to know what is the full capacity, what is a advanced capacity. So we still have some efforts to do to understand really the metrics when it comes to looking at the capacity of our members. But one of the very positive developments we're seeing at the moment is we're developing a new global maturity index under this Early Warning for All initiative, which both will help us understand, a more common way of measuring progress here, but also will help with with centralizing a lot of that information. When it comes to looking at the ways of engaging with countries, one of the most effective development approaches that we see is really this twinning of institutions between, for example, national meteorological and hydrological agencies, so often within a region. So, the cooperation has developed between, say, the South African Weather Service and other institutions in the region. So it's important that we're able to put in place the effective financing modalities that incentivize those types of cooperation. And of course, in this, you'll be very familiar, one of the values of our community is this mutualization of, the certain services that, so that not every country has to develop, each one of has to reach the same level when it comes to modeling or capacity building training. And a lot of the member states will be taking on functions for a group of countries within a region, and that's one of the real values of our community, and so we have to be able to both finance the regional functions. So if South Africa are providing serving as a training center for the whole region, that we should be able to help support their capacity, as long as in addition to the national functions, also those regional functions. Obviously, of relevance to our discussions today is how do we better tap into the science, the applied science, when it comes to our capacity building efforts. At the moment, we're not still very good at this. I think we function much too much through traditional development partners, and we know that if we work with research institutes, academic centers, they not only help us, sort of quality check the kind of work we're doing, but actually even provide technical assistance and support to other countries. So it's something we'd like to get a lot better at. I asked my colleagues to look across our portfolio and see some of the areas where we're seeing priorities emerging, where we could benefit more from the academic research organizations. And this is only a very small perspective of what could potentially be supported, but obviously, we heard quite a lot this area of infrastructure, observation, nowcasting. This is where we're seeing the most progress, the most innovation. So you can imagine for us, if we're financing infrastructure in developing countries, and we're told that, the quality of satellite data is can be soon used for nowcasting. Now that has quite considerable cost implications on the kind of investments we're doing in countries. So we're always keen to understand better where those innovations are. This area of interface between the physical hazard and the human impact that's been discussed a lot over the last days. This is an area where we're actually seeing not enough research or science in this area. We'd like to be able to see a lot more to help us understand the impact of some of the work we're doing, and measuring the accuracy and value through forecasting and the whole communication chain. And I think it relates a little bit to the work that Bruce is doing with his group, understanding also the accuracy of of predictions and how do we communicate uncertainty is obviously something that's very important also for us in our development work. So the last area is obviously is this: how can we, what does a success look like, and how can we more effectively communicate on the results of our from us, for example, from our investments. For you, it's for your research. For the government, is of their national systems and early warnings that they're issuing. And so this, what we're looking at is we try and tie everything we do. So our investments are all, the effectiveness of our investments are always tied into what we call here global goals and targets. They're actually not global, they're national targets that we aggregate globally. But we know that we have the Sendai framework, which has specific targets related to this topic: loss of life, economic loss, access to early warning. These are all targets that all the countries, including South Africa, have agreed to continuously monitor and report against. And those are directly tied into the Sustainable Development Goals on poverty. We also now have this opportunity of this early warning for all framework, so we can show common progress against this this global framework. What we're trying to promote is a reduced set, a minimum set of metrics that we can all measure ourselves against through science, through our technical assistance as governments. So with this, it's a very complex area. We can have a lot of indicators on many things, but we do need to have a common set of things that we all agree we need to measure ourselves against. And of course, everything we do has to be measured against the wider socioeconomic benefit. And loss of life is one of those such indicators. So my last slide, I just also did want to provide some information on the type of financing that's currently available to countries. We have two dedicated financing mechanisms currently in WMO. I'll start maybe with the Systematic Observation Financing Facility, which is set up recently. And their countries can benefit from two types of support. They can get support to assess the status of their observation network. And that is done through peer-to-peer work from other Met services. And South Africa has been leading on this with a number of countries. And then the countries can also benefit then from actual investments into their observation networks. And this is all linked to the Global Basic Observation Network, which is a new set of standards that WMO has set in place when it comes to observations. And the other mechanisms is the CRUISE, the one I currently manage with, which is a trust fund, which is actually administered by the World Bank. And here countries can access either what we call country projects. So it's financing to help build technical assistance of the national institutions. They can also access regional projects, and we hopefully are going to approve some financing for the SADC region this year. We have a mechanism where countries can access very quick support for technical assistance. So if you have a specific research area that's urgent with regard to the national system, you can actually tap into those kind of financings through a window which hopefully has a limited amount of overheads. And we also have an agreement with the Green Climate Fund, where we basically de-risk and facilitate for them access to up to 25 million for each country when it comes to strengthening their early warning systems through this Scaling Up framework. So this is a quick overview of some of the mechanisms that are currently available to countries through the WMO network. And I think that's it for my presentation. Thank you for your attention.
Thank you. It was a great overview over the WMO and the possibilities. So I hope you take advantage of it for those who have never heard about it before. So let's now proceed to our next talk. It should have been given by Jeff Smithers, but unfortunately he cannot be with us due to health reasons. So we wish him all the best and hope that he will recover very soon. Instead, we have Cobus du Plessis, who will he's also working on the flood, so he is a good substitute. So the title is the National Flood Studies Program for South Africa, Overview and Development to Date.
Thank you, Chair. Thank you for the opportunity. And let me just start off by again apologize for Jeff not to be able to speak to you today. So I'll do my very best as the second guy standing in. So let's see how things will develop. My duty on task today here is trying to inform you really about the National Flood Study Program in South Africa and what we are doing in that context. So what I would like to do is to give you a brief background in terms of a design flood estimation. We talked about, you know, values, and there's time scales to these things, just as a bit of an understanding thereof. Why do we need the National Flood Study Program? Why is it there? The background and how we developed from the years gone by, the challenges of the implementation. I don't see many added factors here as what we've discussed already, but nevertheless, that's the general problems is our problems, project-specific problems as well. The overview of the progress would like to give you some indication of how far we've come in terms of some of these new developments that we've tried to introduce, and give you some of the selected examples of specific outcomes and results of some of the research that we've implemented as the National Flood Study Program. And then a bit of a capacity development and some concluding remarks regarding that. So what is a design flood? So this is on the, you know, how do we deal with these extreme events? At the end of the day, we need to get to a number. And that number do have a probability that it will occur. And that is associated with risk. And we need to decide which risks we are prepared to take with that number. So we talk in layman's terms about the recurrence interval. So we talk about a 1 in 100 year or a 1 in 10 year flood event, which simply just means there is for a specific number, 10 cubic meters per second, whatever the number might be, a 10% probability that it can happen in any year. And that's the number that we are working with. It's not an observed event. It is an estimate. That's what it is. It's an estimate of what we need to deal with. And that estimate is based on a lot of information that we feed into the system and our decision-making processes. So why are we using these floods, besides the disaster side of it, is all our infrastructure, our culverts, our bridges, they are all being designed based on these flood calculations. And therefore, we need to be able to be as accurate as possible with that. Any inaccuracies, which there are many, will have implications, whether it's costs or lives, there's implications with those. For us, or for most of us, where we live, the flood line is the problem. I mean, we developed below a certain flood line, and if we do that, we are exposing us to those risks associated with that probability of that flood going to happen. So that's one of the biggest challenges in our country as a developing country, to make sure that we provide adequate development opportunities, but in a safe space. And the flood line is being used for that. And then to manage our floods in general is one of the key aspects of why do we need to do this. So I accept that, you know, not two of you in this audience, look at how brave I am, will know 1% of what's in front of you. I've had this workshop or a workshop yesterday with engineers, and they were not quite sure what's all up there. So the slide is simply just there to show to you that there are various ways in how we determine these flood peaks and the probabilities associated with that. But many of them are not used in everyday applications. And the important thing here, I can't show it everywhere, but the important thing here is to look towards the color coding, that many of them has been developed prior to 1990. That's even a softening of the whole issue, and I'll get to that details just now. So the methods that we are using is quite old, and they need to be updated very seriously. And it's, as a result of that, there was quite a number of publications being produced that people are telling us, look, these methods is suspect. You need to look at them. They're old. You have to spend some more analysis on that. Most of those methods are actually being developed in the late 1960s and the early 1970s. And that's the approaches that we are using at the moment, quite old. Many elsewhere in the world, there are many new initiatives and new ways in which we can analyze these floods and how we should introduce those and make sure that we understand those. And beside that, we've had about 40 years of additional information available to us to actually make sure that our different flood determination methods are still valid and still working. Then the Water Research Commission commissioned in 2013 a working group to look towards all the flood determination methods, and there was a complete report on which the findings, in which the findings were reported in, and there was a whole list of priorities and indications of why do we what we should do in terms of update all of these methods. So based on that, in 2013, there was this National Flood Study Program has been created. And the whole purpose of that is to look towards the different input parameters in how you determine floods. And there were 5 working groups being created, being the rainfall and analysis part thereof, because rainfall is the primary input parameter to all of our flood calculations. Then the flood analysis methods themselves, the hydrological data, the flow data that we measure, the products and use for flood estimation, how do we convert this theory to practice, the tools that the practitioners need to use, and then the institutional arrangements. How do we deal with the different institutions that need to take this number to a policy to be implemented? How do we decide where the 100-year flood line needs to be? We need to take that all into consideration. There was a plan and a budget being approved. The Department of Water and Sanitation was on board. SANRAL, South African National Roads Authorities were on board. And in 2016, we came up with 19 research projects, which we think we should follow to try and address that outdated way of calculations at the moment, what we do. At the time, 2014, it was about 28 million that we needed. Mostly, that money was needed for data, to update our information, our rainfall information. We can't really move forward very effectively without that being in place. We undertake over 8 years certain priorities to be implemented, and we also decided to follow a multi-stakeholder approach to finding solutions. That means that we will probably, at all the academic institutions, we do have representatives on that to try and see how we can join forces. Also because we lack capacity at research institutions to actually take up these challenges. But there's also quite an extended number of practitioners helping us to get to this correct methods to design these floods. And then, of course, our project funding needs to be rolled out. And I've got a list there of all the participants there. We've got international cooperation through international cooperation through the Bath, University of Bath. We've got the NRF, the Royal Academy of Engineers. All of them is part of our quest to try and find it. And that, of course, ladies and gentlemen, in terms of our data, is a scary graph that I'm showing you there. That gives us the number of working rainfall stations and river flow stations that we use effectively for our water resources. And the bottom line of it is that we are sitting now at a level that's close to 90-70 in terms of our river flow gauges. But in terms of our rainfall, working rainfall stations, we have never been as bad as what we are now. And that's a problem. We shouldn't be there. The challenges of implementation really is the funding to commit that. That's no new story. We all battle with that. The access to the information that is supposed to be available to us. And I've mentioned the research capacity and then the whole network going down. I'm going to skip on this one. That's the progress that we've done to date. Some examples, there are 4 of them, just as an indication of the type of research that we are doing as the National Flood Study Program. We are looking towards different gauging stations in our country. We've analyzed, in this case, 157 of them in different catchment sizes, and we found the error in terms of the different methods that we are using compared to the actual measured data. In all of that sentence that I'm giving to you, there are room for errors. And nevertheless, the story is not a very good one. We found significant, 700% overestimations, 800% underestimations, depending on what sort of method you are using. For that reason, it's obvious to say we need to update these, and these needs to be looked at very careful. Recently, we've updated the regional maximum floods. We are now in a position, early this year, we've finalized that, and that's now available to the public for general use in practice. We've updated the expected regional maximum flood that you can expect in a certain region, depending on the area. We've updated that. It was last done in 1988, now available. We look towards aerial reduction factors, and just to inform you about that, the point rainfall, that you measure at a specific station doesn't help us. We are working with catchments, multiple rainfall stations joining, contributing towards a runoff at a specific point in time. And for that, we need to apply aerial reduction factors. There were significant differences in the methods that we've applied. We've updated those now, and these are available to us. We've joined forces as well with the Institute of Municipal Engineers. They are on the front face of battling with the implementation of these flood lines. So it's quite a challenge. We've joined forces with them and the Water Research Commission, and we've compiled some sort of guideline. I say some sort because the decision that we've took for this guideline is that we will not publish anything there that was not peer reviewed. So we know that there were certain processes that we've upgraded, but we haven't been peer reviewed yet. So everything in that guideline, which we are busy rolling out now. I was yesterday in Joburg with a workshop with the city there to try and give them some indications. We do have these as additional tools available. What did we achieve as the National Flood Study Program as a collective group? We've graduated this far 8 PhDs, 15 master's students doing different research. We've got 6 registered PhDs and 6 masters running at the moment. We finished about 8 different research contracts in that space, published about 36 journal papers, and addressed more than 35 conferences internationally to try and put our case forward. To conclude, Chair, I'm done almost, is that the National Flood Study Program, it is a multi-stakeholder engagement process. We've got all the big role players on board with us. We meet annually. We review our progress every year. I've already mentioned that it's multi-stakeholder and institutional. We do have our international collaboration. We did provide, in our opinion, with the limited amount of money available to us, significant outputs already, and we hope that we can proceed with that. There are some progress to date with the modernizing of our methods, but by far not enough. We have to deal with what we've got at the moment till we've updated all of them. Data and funding, data and funding, data and funding. So we carry on. And then we try to collect all our research. We talked about the platform. I know it's on a different scale, but in terms of floods in South Africa, we try to publish all of that on a Water Research Commission based platform, and the website is being provided there, and I trust that you will have your that information on the slides available for further questions further. Thank you, sir. That's it.
Thank you for a great talk. I must admit that, I'm myself a flood level victim, and it happened this last week. So we have an old house, and we want to tear down one extension, which is about 20 square meter, and replace it with a new one. And it turned, but the thing is that our floor level is 12 centimeters below the 200-year flood level. So, and since we're going to change shape of this extension, it turns out that 6 square meters are not covered by the old footprint of the building. So the local government is forcing me to raise the floor 12 centimeters in these 6 square meters. So what happens? Well, I go to the newspapers and there's an outcry. So we'll see what the final result is. But I think it still is a very important job you are doing, and the floods are certainly becoming important. But it can have some kind of funny aspects, as what we are experiencing back at home. So thank you. So now we move on to the flash talks, and the first one note is Elani Heineke. There we go. So investigating a rare mesoscale convective system over the Central Karoo Western Cape, a case study.
Hello, everybody. Thanks very much for the introduction. So the case study that I will be talking about is a very rare mesoscale convector system that was over the Central Karoo of the Western Cape on the 3rd of February this year. So very recent as well. So a lot of research that we're still going to do about it, but we thought of sharing it with you guys at this conference. So first of all, can I move down, please? Okay. So the 3rd of February was not the only date where we had a severe thunderstorm. On the first week of February, there was actually 2 severe thunderstorms. The first one was on the 2nd of February near Citrusdal. As you can see with the impact that they had, there was a large amount of small hail and large hail as well. So this was actually the impact of this large amount of small hail tore agricultural netting as well. Then on the 3rd of February, if you just go down a bit more, please. A severe thunderstorm that developed near Ceres moved down to the south and contributed to estimated wind gusts of 100 kilometers per hour. So this contributed to power lines, ISCOM power lines being blown over. So the impact of this was that for a couple of weeks, there was no electricity over towns of the Central Karoo, which also contributed to water outages in that region as well. Now, to add on this impact, there was a heat wave from the 4th until the 6th of February, which actually exaggerated the impact of this severe thunderstorm. Now, the question was, I contacted Dr. Blamley and I said to him, I know you've done some studies on MCCs, your PhD. Is this a MCC? And we went on and we did some analysis and we classified it as a mesoscale convective system. So if we go up, please. So a mesoscale convective system, more please. So a mesoscale convector system is just basically a large, organized, long-lived convector system that is usually associated with severe thunderstorms. So in order to classify it, it needs to at least be long-lived, longer than 3 hours, and then it should contain a precipitation area exceeding 100 kilometers or more in one direction. So the interesting thing about mesoscale convector systems is they play a key role in the hydrological cycle and global circulation through the redistribution of energy, heat, and moisture in the atmosphere. So it's a very vital type of severe thunderstorm for South Africa. Now, according to climatology of MCSs over South Africa, they usually occur over the eastern parts of South Africa. And this is mainly due to the abundance of low-level moisture from the southwestern Indian Ocean, so over the eastern part. However, this mesoscale convector system was over the western interior of South Africa. Now, the question is, why did it develop? And interesting enough, it was not due to a cut-off low system that you would think. It was a normal, if you go down, please, very normal type of situations where you have favorable conditions for severe thunderstorms. So you had sufficient instability values, you had some wind shear, but also just more down, please. The surface conditions were a low-level pressure system just southwest of Cape Town. There was good amount of low-level surface conversions over the area of concern, and then just the upper air trough west of South Africa. So not just typical, it stands out, it's gonna go down today. So what we are now going to do is for our future studies actually to delve into deeper to determine what other factors are contributing to the development of this mesoscale convector system so far west of South Africa if you compare it to your climatology as well. Yeah, that's basically all from me. Thanks very much.
Thank you. So then the last talk before we have the tea break, that is Johan Malherbe, and he's going to talk about the 2023-24 summer drought as attracted by agriculture drought early warning systems for South Africa, ADUBs.
Thank you. So we had quite an intense drought, as many of you are aware, over the central parts of the country this year. We had really hot and dry conditions. And this station data in the Northern Free State just demonstrates that this starts in early December 2023. It ends in late March. And, you know, the surface graph at the back is the maximum temperatures for each day. And the bars are the rainfall. So you can see in December and early January, it rained quite a lot and it was cooler. But then since mid-January, it was really much less rain, very much below the normal, and temperatures shot up. So there was a typical flash drought situation where you had wet conditions earlier, farmers could plant all their crops they needed to plant and so forth. And then the rain started a bit, the rain stopped and it became hot and dry later. So the agricultural drought early warning system, you can find it at that link that you can see. It has a few indices that try to track drought. And we just wanted to see whether we could see the effect of this flash drought on the crops. So I got some data from the Department of Agriculture on the anomalies per municipality or district for maize production this year, and then correlated it to various indices that we make use of. So the one you can see here is the one that looks through satellite data at vegetation data, and it is based on the normalized difference vegetation index. It's called the VCI, only for a certain 16-day period. And now you can move the slide up. And the ones here would be what we modeled according to our daily rainfall interpolations and temperature and sunshine interpolations for maize production during the year. And that is a water requirement satisfaction index. We also looked at the fourth index, which is a standardized precipitation index for a 3-month period. And if you go down a bit more, what we saw really nicely over this entire region shown there, and also on the first map, which depicts the main commercial crop region, is that these indices really did a good job at the spatial variability of the drought. And then, as you could expect, the shorter term indices had a much better correlation, very significant, like the vegetation condition index that you saw above. The one that had the worst correlation was the standardized precipitation index, because that one is calculated on monthly data, and it continued raining into early January, so there you couldn't see the real dry area very nicely. So for these flash drought conditions, we did see that at least the crop modeling, as well as a shorter term vegetation condition index, showing you what's happening on the ground in terms of vegetation data, really plays a very good role in telling you that there are agricultural impacts during a drought that only focuses on a specific part of the season. Thank you.
Thank you. So now it's time for a break. So should we take 30 minutes or?
Yeah, we're a bit ahead of schedule. I thought maybe, Jan, there'd be an opportunity if anyone had any questions for our two keynotes before we break for tea. If there were any questions or comments for them. I wanted to ask John Harding about, if you don't mind, which was just when you say funding is available to member states, that means the governments, I assume. Where are you, John? There. It's the governments that they have the funding available. And then just to remind us, the Sendai Convention is a disaster risk one. It's not specifically for weather, or is it specifically for weather? Maybe you can just answer from there.
Thanks for those questions. So no, the funding is actually provided, in the context of these kind of financing mechanisms to development partners. So actually, a program, if the program was started in this region, it would be implemented through the World Meteorological Organization, for example. So and they can enter into partnerships with many different types of institutions and within the region. So we don't provide direct financing to the government through these financing mechanisms. There are other financing mechanisms where we do, but not these ones. And the question on you mentioned Sendai, yeah? Yeah, so Sendai has a very clear multi-hazard mandate and scope, and you may recall, I know it was a few years ago, but Sendai was the first time when the sort of collectively as an international community we moved beyond natural hazards to include also technological disasters and biological hazards, so all the pandemics and so on. So, and if anything, Sendai even widened the scope of our collective approach to these, which I think was a good thing, but challenging, of course, when it comes to the responses.
Thanks very much. Are there any other questions for Cobus or for John, or for the two flash talks, if you care? Thanks.
Thanks. Yeah, I was really interested in the floods presentation, and I guess I wanted to ask a couple of things. The first one was, you talked mostly, I think, about rainfall-based and riverine-based flooding. I wondered whether there was any join up to the coastal flood risk, whether that's something you can comment on. And that kind of leads me on to the second question a bit about whether there's any considerations of interactions between coastal water levels and river outflow. It's a sort of compound hazard, which is gaining quite a lot of interest at the moment, compound risks.
Where are you? Okay.
I can't answer your question. No, look, the coast or the wave action is a completely different science towards the flood analysis, and the combination is disastrous, and you can't predict that. One thing that I just want to also indicate is that early warning, we talk about, I know eThekwini, for example, is well in advance in terms of the early warning systems for flooding specifically. You need to keep in mind what we try to achieve from a flood management point of view. The response time from a rainfall event is at its worst if it is for the duration of, if the rainfall event is for that duration of that response time. Most of the cities do have a response time in the order of no bigger than 3 hours. So if your early warning needs to help something, you need to be able to get the message out in 3 hours. It's not going to happen. It's not going to happen. The coastal protection side, a completely different study than what's been done here, was undertaken in a challenge that we've had as local authorities, and I'm wearing my Institute of Municipal Engineers hat for this one. When you have the stormwater outlets on the surface, on the beaches, and they just get destroyed over and over and over and over again. So we need to look towards those amenities, and there was quite a bit of research being done, but it's completely different from what we try to do here. So response times is one thing, and then while you are giving me the gap, sorry, is in terms of, we've also updated Jeff and his team, Jeff Smithers and his team updated the probable maximum precipitation for South Africa. For us, it's important in design of the spillways of dams, etc., our higher risk areas. And data was, again, it's really hampering us to try and analyze what's available, and we need to look to alternative ways of doing that. But at the end, their research group there, as part of the National Flood Study Program, couldn't find major differences in probable maximum precipitation. I've done the regional maximum floods, and that didn't change either over our recorded period. However, additional data allow us to identify in smaller detail. So I think there's a lot of work for us to be done in data so that we can be more accurate in an uncertain environment.
Guy has a comment, but I have a question following yours about your work. I just want to understand, the products that you have, they are, if you like, static products in the sense that they are an assessment of what the risks are in these various locations. Can it be used operationally? And how can it be used operationally?
Yes, so there are different ways in which we look towards these flood. We talk about event-based approaches. So you look towards a specific rainfall event resulting into a specific flood event, and you need to determine what's the probability of that occurring on a catchment with certain probabilities of a wetted catchment area, etc. So these are event-based, and you analyze those deterministically with models, taking the rainfall on the catchment and see what the flood peak and the flood volume, or the hydrograph as we refer to it, looks like. So that's the one way. We are moving towards what we refer to rainfall on grid, the more two-dimensional modeling of what's actually happening with a rainfall event. It's extremely data intensive. We do have the computer power, but garbage in, garbage out. So we need to make sure that we've got all the correct input parameters to model it in real time. What's happening with that hydrograph, what's happening with the rainfall event as it goes through the catchment. The capability is there. It's a matter of dealing with the data, the availability of the data. I think, is that it?
Question, maybe you can help us. Apparently, Roland Schulze has updated the hydrological work that was done all the way up till 2000. We had one of the most magnificent data sets, probably one of the best in the world at minute degree scale. Apparently, it's been updated to 2020 or 2021, 22. Why is that data not available? If it's been done, why is our community still starved for the data?
You shouldn't be. It is available. In that, I must just give you, in that guideline that we rolled out, all the website is there. It is available. I must say that in the context, the National Flood Study Program, we've made it our mission, because we are battling so much with data, to make as much as possible available to anyone as far as possible. There was quite a big problem. Each and every one of you in this room would probably understand the challenges with having a maintained data set. It costs money. You can't just allow a PhD, well, let me be softer. You can't just allow any student's work to be published on it unless you are very, very sure and went through a peer review process. To manage that, take money and effort. One of the frustrations for us is, and I'm sure everyone can share it with me, is if we want to use rainfall data, each and every one of us, for whatever purpose you want that rainfall data, needs to do the gap filling, making sure that the data is consistent. Why can't we just get it done in the first place, and then we can save a hell of a lot of money if that's been stored somewhere for us? It's not the case. But back to your point, Prof. Soldier's excellent work on ground conditions and all of that is available, and it is free, and it should be accessible for all of us.
Folks, it is 10 minutes ahead of schedule. Let's go have some coffee. Depending on what the mood meter says about things, we will call you back either at 4 o'clock or 10 to 4. So we can maybe finish 10 minutes earlier. So let's have a break now. There's some people at tea. Should I blast them with a horn? Didn't move, Bruce. You're still chanting away. Okay. Thanks for holding out the whole day. Hector is going to chair the next session. I just have two quick announcements. One is, if you need an attendance certificate for this conference, which some of you will do, please make sure that where you've signed your name when you came in this morning on the attendance register, to please tick that box. And then we will send you a electronic signed version of that. And the second is that my colleagues have put some post-it notes on the tables. And if there's any question or point that you want to make that is not, you don't have an opportunity, you would like to write it down, please do that and they'll collect them later on. So we are slightly ahead of schedule, which I never thought I would say, I have to say. And so Hector will take us to the end of the day, and then I'll say one more thing at the end of the day, and then we can move on. Thanks, Hector. I've got a timer.
Yes, I would be happy if we can start. All right. Thank you. Good afternoon and welcome everybody. Welcome to the continuation of session 2, the session on observations and early warning systems. We have 2 keynotes. The first one is from the South African Weather Service, Dr. Don Matlobo.
Well, good afternoon, ladies and gentlemen. Yes, I'm Don Mahlobo. And as you can see, my title, Climate Service, a plea for all South Africans. Yeah, so before we talk about climate service per se, let me just take you through the foundation of climate service. That is the basic or the current situation we are facing right now. So these are the statistics from 1951 up until 2023. And as you can see, we have a relatively warm 2023, especially in the northern and northern interior. And in the south, we have temperatures were just near normal. So another fact is that this was approximately the 8th hottest year on record since 1951. So when you're talking about heat, when you're talking about heat, so 2023 was the 8th hottest since 1951. And then we've seen through our trends that there was a warming trend of approximately 0.17 degrees Celsius per decade. So you will see, even you can see in that in the figure below. Let's look at rainfall. We had near normal rainfall amounts that were received over most parts of South Africa in 2023. And then with the exception of the northwestern interior, which received well below normal rainfall, as you can see in the figure below. And then we have some regions along the coast and extreme east that receive well above normal rainfall. If you can see at Mpumalanga there, that bluish, darkish bluish shade, showing that they were very well above normal rainfall conditions over the country. Trends, let's talk about trends because we're talking about extreme climate events today. Let us look at the trends in extreme events. So source, we provide an annual extreme climate indices on a yearly basis. So each and every year we have a publication that we issue. And then with all the indices, most of the indices that will give you a general impression of the trend in weather and climate extremes in South Africa. But this we've extended also to other parts of Africa. So the trend analysis stretched from 1921 to 2023 for rainfall and 1931 to 2023 for temperature. So you can, as I've said, there's generally an increasing trend in temperatures. So these are some of the figures that we issue when we're doing our trends analysis. We have a number of indices, temperature indices, we have a number of rainfall indices. So these are some, I won't talk to each of them, but in general, hot extremes are increasing. So the hotter or higher temperatures are increasing and the colder extremes are decreasing. And then if you look at other research, it has shown that over the same analysis period, records were broken at significantly higher rate. So some of the stations found that there was, when you talk about the breaking of a record, so the highest temperature ever occurred, or the highest maximum temperature, the lowest temperature, those are some of the records were broken. So last year, we had a number of stations that were recording extreme temperatures. And then hot days and nights are increasing, and cooler days and cooler nights are decreasing. As we have seen, also we have seen that morning frost have decreased over the interior. We've also seen extended periods of hot days, and in which is the opposite is true for colder nights. So there's been a decrease in cold nights. Okay, so what does it tell you? What does it say to a layman on the street? So we have all these climate information, weather information, but it should send a message, a direct message to a layman on the street or any other user, because when you're talking about our community, they are the users of climate information, and whatever we have, it should talk to them. I think I've missed a slide there, but it's fine. So, and that's the concept of the National Framework for Climate Services. A number of speakers have spoken briefly about the NFCS, and then it was conceived in 2009 and as the Global Framework for Climate Services. So there've been an evolution of this climate of the GFCS to talk to the NFCS. So there've been a number of steps that were taken, and we're currently working towards it. So we're getting there, if we're not already there. So the GFCS pillar, remember when GFCS is for the Global Framework for Climate Services, where the NFCS is alluding to. So it is formed and it is based on pillars, which are the user interface platform. I will talk about this. The Climate Service Information System, observations and monitoring, research, modeling and prediction, and capacity development. So what we do here, we mainstream all climate information to sector-specific products, so that whatever we have, it talks to the users out there. It talks to the community or the climate community out there. And the NFCS, when you talk about the NFCS, is not only a source thing, it's not a DFF thing, but it is for all of us. So by mere coming to this conference and taking part, you are either a climate producer or a climate user. So you form part of the NFCS. The user interface platform. So that is where we engage with a number of stakeholders. So we're talking about here the collaborative engagement platform for the climate service community in South Africa. All climate service providers coming together to form or to answer a question or to fill a certain gap. And then, as I've said, we're mainstreaming the climate information to talk to the user. So here we need tailored climate information products and services. What is available, or what is the relevant climate product? We have a number of sectors, but one that answers the user's needs, that is what we need to focus on. We have different users, and each of the users that we have, they need to be serviced. Agricultural experts, farmers, school children, community leaders, all of these are climate service users that need our climate services, and they rely and they look upon us as climate service providers to assist them. As source, there are a number of products that we are currently have to assist or to lend our hand to our climate users, and the ranges from aeronautical climatic summary, that is for aviation services, air quality data. So we have a number, your daily weather bulletin, that is for any person who wants to know about the current minimum and maximum and rainfall condition for a particular day. We have district rainfall stats that are quite useful for municipalities, parameter return periods, there are rainfall return periods, rainfall downtime reports that are used by construction industries. We have recent climate, satellite data, a number of products. But the list should not end here because we have a number of climate service producers. So it should not be only about the source products. So that is all NSCS is all about. Another pillar for NFCS is the Climate Service Information System. As you can see, the Climate Service Portal, this is currently hosted by the DFFE, and then the SION as an organization, they're very engaged in this portal. So if you go to the portal, just before we go to the portal, you know, in one of the groups we had, they talked about a hub, a common hub where everyone can come and see what climate information is there. And this is the starting point. The climate service portal or the NCCIS is the starting point for this. It is not hosted by SOURCE, but it's hosted by DFFE, and then Sion is quietly involved in this. So you can see there, if you go to the portal, a list of source products and services. There's an atlas of the climate and weather related data. So there's a number of products, but this could be better. There's a room for improvement because currently it's only few organizations that have their products on there. But if we work together, I think we can have a wonderful portal. We are working on that, and we're very positive that we'll have a portal that will talk to our users. Even the users, they need to access this information. They need to know about the products that are out there, and the portal is all about that. And we've also talked about the Kelium as having a number of weather events or weather events. But we're moving now from Kelium. We know that Kelium is one of our selling products as SOURCE. But we're moving from that. We're moving to SWEDE. SWEDE is the severe weather impact database. So what it has, we're not talking only about the weather events, but also about the impacts that are related to the weather events. And these are housed in the database. As you can see, we have in this figure, we have different types of events, your drought, flood, and then each of these weather events, we should assign a sort of an ID, and then that could be linked to the event database that is hosted by SOURCE, which will talk to the loss and damage community database, which is currently being sourced or run by the National Disaster Management Center. So the loss damage community database will feed into the event database, and the event database will also feed into the loss and damage database. So we're moving towards this. We're working together with, I think I've saved a wrong presentation. We work together with the CU2, the Central University of Technology, in making sure that the database is working functionally. Currently, we are concluding the work, but the events are only based on 3 municipalities. There are plans to scale up those events or the suite to accommodate all municipalities in South Africa. Let's go to the observation and monitoring as another pillar for the NFCS. You've talked about the deteriorating observation infrastructure. Yes, it is true, not only for SOURCE, but for a number of organizations. This is a pain and it's our weakness, but we really have to come together to work together in making sure that we are taking care of our observation infrastructure. There are talks about a funding model that should be advocated for a national observing network. So these are some of the talks, because some of the issues with climate data, it is because some of the data policies, we don't have an open data policy. Some of the data policies are closed, so we sell the data. Some other organizations that are giving the data for free. But if we can come together as climate service providers and say, we really need data, what can we do to assist SOURCE to ensure that data is available for all of South Africans? So this is not our only SOURCE responsibility, but it is responsible for all climate service providers. So we're meeting with some of the work that we're doing, we're meeting with relevant stakeholders to address key issues and look at the observation network across the country. So if you can look at this map, we have the SOURCE automatic weather stations and automatic rainfall stations. We also have the ARC, I've seen Dr. Malebe, the ARC automatic weather stations in this figure. We also have DWS, the Department of Water and Sanitation. So as a climate user, if you need maybe a data, I don't know how to point with this. Even the data maybe at somewhere in the Northern Cape, and then there's no station for data from the weather service, it should be easy for a user to say, okay, but then there is a station that belongs to ARC. How can I access the data? So that is the vision of the NFCS. The climate that is out there, the climate products that are out there, it should be from all the climate service providers. Data that is out there, it should be from all the climate service providers. I'm not talking about now the data policies. I mean, this is a subject of another day, but this is the vision that we have. Research and modeling here, as the weather service, we are doing research and modeling from short-term to scenario scale. We also collaborate with academia, like your VEST-GCI for climate projections. But I think there's also other players in the sport. We have your UCT with their climate projections. We have UP. We have a number of players. And these are some of the things that the NFCS is advocating for us, working together, collaborating, and making sure that our users are being serviced. Also, these are some of the stations, the network of South Africa. I won't go to this slide. We have automatic rainfall, automatic station, automatic rainfall, and a number of radars, lightning detectors, and all of that. All of these are supposed to service the community. I've heard one of the recent presenters saying there's problem in funding, there's problem in data. Yes, that's the problem that we're facing. Even though we want to give data for free, but we also want to sustain the weather service. So funding is a problem here. Under the pillar capacity development, as SOURCE, we are a registered regional training center. So we offer meteorology and climatology education for Africa and the rest of the continent. And we do collaborate with academia as other service providers. For example, we have an MOU with UP. We have close working relations with VEST-GCI, TUT, University of Limpopo, UKZN, CUT. Yes, a number of universities. So how do you go forward? Let's start with what we have, irrespective of data policy, because now data policy, they tend to be better when we need to sit down and talk. They'll say, no, SOURCE, we don't want to give your data. Data policy is a subject for another day, but let us start with what we have. The different policies that we have, they don't matter, as long as we sit down and talk and see how we can attack the elephant that Prof. Whitson talked about. We have different strengths and capabilities as different organizations. So if we work together, we'll kill a mountain. We all have to do our part. As SOURCE, as CSIR, as SCION, as academia, everyone has to dip in and see what they can do so that we can service our climate users. Whose responsibility is it for the NFCS? We have different responsibilities, but to service the climate service providers, it is all on us as climate service providers. As we sit in this room, let us all think about our climate service users that needs our attention, that need our assistance. In conclusion, the climate service user community is looking up to us as a collective to assist them. And it is time for all South Africans or South African climate providers to unite and work together with users in making sure that the climate service community is serviced. Can we work together? I believe we can. Thank you.
Thank you. Thanks very much, Dawn. The lady with the keys to the observations. Thank you. The next keynote is from William Bond, trying to understand the behavior of wildfires over the urban edge. Thank you, William. 20 minutes. Yes.
Right. Well, something a bit different. And there is a bit of climate in it, but it's mostly about fire. So the vegetation around here, up in the hills and the mountains and on the plains, is called fynbos. It's a shrubland. It's crammed full of remarkable species. It's world famous, and most of the plant species are unique and endemic to this part of the region. So it's a fantastic asset for South Africa. It's extremely fire prone. It burns in a cycle of every 5 to 35 years. So just when you've forgotten about fire, it hammers you. One of those things. The plants after a fire look pretty bad, but it's only temporary because most of the plants in the system are adapted to fire. So they'll come up as seedlings stimulated by fire, or they start flowering because the flowering is stimulated by fire. So it's a fire-adapted vegetation. It needs fire. Now, this is a bit tricky when cities go up next to it. And when the fires jump over and burn into the cities, like in this fire at UCT, we have problems. And this sort of problem is common in many of the Mediterranean climate regions of the world, such as California, Australia, and the Mediterranean basin itself. There are huge problems with damage to people and properties caused by wildfire. I put the two South African examples up here. UCT, buildings lost, lives lost. The Knysna fire is considered South Africa's worst so far. We get off lightly compared to California, 18,800 buildings lost in a single fire and 85 lives lost. Or in Australia, 2,300 buildings lost, 173 lives lost. So this is a major event, and the world is thinking hard about what to do about it. In the Cape, big fires are entering settlements. So Western Cape big fires include Imizamo Yetu outside Hout Bay. This is an informal settlement fire. The fires start within the settlements and move out. So I'm not going to talk more about them. I'm talking about the fires starting in the veld and crossing over into the cities. And the worst fires so far are the Knysna fires of 2017, the Overberg fires of 2019, UCT fires of 2021, and they continue. What to do? And this talk was prompted by articles in the media arguing that the problem is inefficient management of the veld by public agencies, that they weren't burning at a regular enough interval with prescribed burns, or they were allowing alien invasives, especially pines and Australian acacias, to go crazy. And I don't think this is true. I think it's only part of the story. And what we're going to do here is to discuss research from California and Australia and some of our own recent stuff, and look at what it says about fires that jump across from the urban edge. So the idea that fuel management is critical has been the central paradigm in the Cape. And that comes from the notion that fires need continuous fuels to burn. If you've ever seen a veld fire, you'll see it through a grassland, all creeping along in a line, the fire line. If the fuel that the fire burns is discontinuous, the fires will go out. So I'm a fire ecologist, so I knew about veld fires, and we're looking for continuous fuels. They're no longer continuous when they hit a tar road, so then the fire should go out. The pines here didn't burn. They did burn in some of this fire, but in this particular shot, they didn't. And when they do get into the canopy, it's called a crown fire, very dangerous, very hard to put out. So the first little note of skepticism from Malcolm Gill. He's an Australian sort of father of fire ecology, if you like. And he got skeptical because of this. This is a slide from one of his papers. There's a huge eucalypt woodland out here. Eucalypt woodlands are notorious for being extremely flammable. But next to it was several hundred meters of grasslands. And next to the grasslands was a well-maintained fire break. And next to the fire break was a tar road. And the fire jumped across all of the grassland and the fire break and the tar road into the suburb here, which is where he lived, and burnt down 400 houses. So not a fuel issue. This is a fire that happened last year in Hawaii. And again, you can see there, it started there. It's a grass fire again, not big pines and so on. And that grass fire burnt into this community, burnt down something like 2,000 houses and killed 100 people. It's the worst fire ever in American history. So is fuel management in wildlands the problem? We need to control invasors, really? In California, my colleague John Keeley and Alex Seifert have done extensive analyses of thousands of houses that have been burnt and to try to work out why they burn and why they don't burn. And they agree that the causes are complex, but they've said basically there are two kinds of fires. The fires that are limited by fuel. So if you put pines in or invasives in, they'll burn more readily. And there are fires limited by wind. And they say that the most damaging fires by far are the wind-driven fires. And the particularly hot, dry, downslope, so-called fawn winds, which are common in other Mediterranean systems. In California, they call them Santa Anas. Here in South Africa, we call them berg winds. And fires during these winds cause disproportionate damage. So this is a recent paper saying, look, these downwind fires cover about only just over 10% of the fires, but they account for something like 60% of the structures that are burnt. And with only a little over 10% of the fires, they account for over 50% of the fatalities. So bergwind fires are lethal. Here's a UCT fire weather over the year. And you can see this is a fire weather index, not the South African fire weather index. It's the Canadian fire weather index, which is more appropriate for Fynbos. And look at that. Absolutely incredible fire weather on the 18th of April, which was UCT's fire. An extreme bergwind event, which most unfortunately coincided with somebody who put a match in. And if you look at a longer time scale, over several years, even over several years, you'll see that that is an extreme event. Extremely unfortunate that it happened to coincide with somebody who put a match in. It's bound to burn, is the point. It's just you want to try and avoid burning it, setting it alight when you have that sort of weather conditions. To decompose the weather a bit, fire suppressors, firefighters talk about the 30-30-30 rule of thumb. So if temperatures are above 30 degrees centigrade, such as that day there, which is the 18th of April, when UCT burnt, if relative humidity is below 30%, as there, and particularly if wind gusts to above 30 kilometers an hour, which is about 8.33 meters per second, then you're in big trouble. And all of those conditions coincided when UCT, the fire, burnt. So it burnt under extreme weather conditions, and so did the Knysna fire, also under bergwind conditions, 2 successive bergwinds. We found no evidence for increase in the frequency of these extreme events. We used weather data from Cape Town Airport, which we trust. The 2 other studies which said it said there was a long-term trend. I don't know, guys. It's up to you. You'll work it out one day, no doubt, why there's a difference between a real weather station and the other data. The spread of human settlements is another major issue. And that is actually, I think, probably the more important concern. So the Knysna fire settlements are spreading, doubling in the last few decades, and they go they're sparse settlements. And the more sparse the settlements, the more dangerous they are. They're really compact and dense, then people get through it. So what seems to be happening is that the big puzzle for me as a fire ecologist was that there was no continuous fuel to burn. So why didn't the fires just go out when they hit a fire break? And that is the major consideration for wildland fires. I've written several papers on them, really good papers, well-cited ones. So it's embarrassing when it's completely wrong in the case of my academic establishment. And urban fires are very odd. They're very patchy. They're very idiosyncratic. That Hawaiian fire I showed you, you may have noticed there was a house in the front that didn't burn. They call it the miracle house. One house burns, the house next door doesn't. And the argument is that these wildland fires release embers and firebrands blown by the wind. And if they land on a suitable ember trap, this fire then ignites and moves into the urban space. In the UCT context, that's where the fire was, burning through the veld. It went right across all this concrete, all this brickwork, and that's the top of my building, burning away. Institute of Plant Conservation, it went up. And, you know, what the hell's happening? And then you look here, this is further down the line. This is 320 meters from that actual fire. And this cypress catches alight. Tar road, these things aren't burning here, this little hedge. But this highly flammable tree went up and smoked. Bizarre. Palms, lethal. They act as ember traps. You can see this chap here trying to put the fires out. And there's the palm tree next to our botany building, which burnt out completely. And there's the burnt out building at the top. We don't know whether this palm was the cause of the problem. Just to emphasize from this drone image, just look how remote this area is here. The fire is way over here, the actual fire, the veld fire. And somehow that fire went all the way down there and burnt this little quadrangle. The one common feature of the trees that burnt is that they're all fire-prone cypresses, popular in Cape Town because they can handle the tough weather. So crazy, concrete steps all around. I would never have believed that this little patch here could catch alight from a veld fire hundreds of meters away. But look at that. It's not all trees that burnt alight. That is the top of the Jagger Library burning there. And you can see it's all concrete all around. And in this case, the buildings also provide ember traps in the form of gutters, eaves, vents. And the consequences, absolutely devastating. That's the African Studies Library, which held some of our most precious documents. So at UCT, the ember traps that caught the embers were primarily palms, lethal. If you've got a palm in your backyard and you're anywhere near the urban edge, cut it down. Strelitzias, sort of palm-like things, and cypresses. Built structures also act as ember traps, eaves, gutters, and so on. There's not much research on this, but there's an Australian study on them and how they work, experimental study, and how you can block them off. There are also trees that were ember suppressors, which didn't burn. And they included liquid amber, plane trees, yellowwoods, but we didn't do a formal survey. 2020 hindsight. But the idea of green belts, avenues of ember suppressing trees or shrubs, may be a very valuable way of trying to fight urban fire spread. So we don't know which trees act as ember sources or which shrubs act as ember sources in South Africa. Perhaps the invasive trees were a source of embers in the UCT fire. We don't know. In Australia, they do have some knowledge of eucalypts. Eucalypts can carry fires 35 kilometers from the fire line. And the record is 45 kilometers. So you have a fire here in Stellenbosch, they will not catch it alight. It's freaky. Do not plant eucalypts. It's an insane thing to do and what the world's doing. If you want to turn into Australia, burnt, a shambles, a mess. Anyway, stop about Australia. But the general idea would be a tree with a larger canopy biomass, a more intense canopy fire should generate more embers, and that these should then travel further. That'd be, we need to work this out. We haven't, it's a guess. It's just a hypothesis. Trees with canopies that don't burn might block the embers. So what to do? Well, fire weather forecasts. Please tell us when we're going to get extreme Bergwind conditions. That becomes the critical weather context. And then what do you do from there? Well, that's interesting. In terms of fuel management, which is what's been widely invoked, it's very important for managing wildland fires. Don't let me put you wrong there. It's critical because the more fuel, the more dangerous it is to try and control the burns. But we don't find it a good predictor of property damage in California. And I don't think it is in South Africa in our few instances either. But you must know what that's all about. The trouble is nothing is known in South Africa about the ember sources or ember suppressors, and more research is needed. My main point about shifting things is, look, we've been blaming the public agencies that manage the fires. What I'm saying is property owners must take far more responsibility. They're the ones who can remove the ember traps. They're the ones who can increase defensive space, manage the fuels on their properties, remove the palms and the cypresses, sort out the ember traps in your buildings, in the eaves of the buildings, in the gutters. How do you manage this? How do you get property owners to take attention? I think work on the insurance companies. They're the ones who are going to have to fork out. If they sent out potential ember trap detectors every few years, and if you fail, if a house fails, you paint a big orange cross on the roof to indicate that you're not going to support those people, that'll help to concentrate the mind. In terms of policy, the most important intervention is to allow more control to the fire managers. For example, they can't do any backburns. If you know about fires, you know that backburnings are essential in, and at least some of the fires that burnt in Betty's Bay were because the fire managers were not allowed to do backburning. So I do want to say there's some good news about the fires, and this is the Western Cape fire teams are good and they're getting better. The government and the NGO resources on internet about fire safety are good and have got better. Schools are teaching fire safety, especially in the context of informal settlements. There's a fire research unit that started at Stellenbosch University, and that's combining with top fire ecologists at Stellenbosch and the CSIR, and that can only be good news. And I want to emphasize that there are colleagues very willing to help from the USA and Australia. Thanks very much.
Thank you. Thank you. Thank you, Professor. Thank you so much. We are still good with time. Thank you. I'm sure we will have some questions for both the South African Weather Service, for Professor Bond. Most interesting conversations. I was praying I didn't have to stand up to say time's up, and people were not going to be happy with me. So we are going to move into the flashes quickly. I know there are questions, but we can. I'll give you a chance to ask questions after the flashes. So we're still very good with time. So let's quickly go to the three flashes that are remaining, then we can engage with our keynotes. So Vuyo will come first, and we'll talk about wind prediction in container terminal areas in Cape Town. Vuyo? Yeah. Yeah. Okay. Thanks. And there's
Okay, afternoon everyone. I'm sure you can tell from the title of this presentation that This work is related to extreme winds in the Port of Cape Town, particularly predicting the wind speed on a short-term scale for operations. So as an engineer working closely with Transnet or TNPA, there's an interest in predicting the wind speed at a short-term scale or short-term forecast horizon, particularly for operations during extreme wind events which frequent the Port of Cape Town in its spring and summer seasons. So yeah, basically a neural network model was used. The algorithm is the LSTM, or long short-term memory network, with ensemble and bootstrapping. The forecast range or short-term forecast ranges are 30-minute, 1 hour, 3 hour, and 6 hour forecast ranges. Data from the Cape Town container terminals, admin building was used. The data set was from May 2021 to October 2023, so 2.5 years of data. And this data was then split into a 70-25-5 ratio for model training, validation, and testing. The graph on the right-hand side is an example of the 1 hour prediction model, which in blue you'll see is the model, so the 1 hour model, and in green is the actual measured results. And ERA 5 data is also used as a comparator to grid points, an offshore and a nearshore point. And as you can see, the 1 hour model tracks the measured results fairly well, and the ERA 5 data either overshoots or undershoots. And overall results of the model, in this table, you can see the results for one month's worth of data, 15 September to 15 October. So the 30-minute model, or the shortest forecast range, performs the best, and the longest forecast range performs the worst. And as you can see, it sort of deteriorates as you go down, and the NCEP data outperforms the model at that point. The graph on the right is a wind-bound event that is outside of the sample data. It happened in December of 2023, on the 8th till the 10th. So in green, you'll see the measured data. In blue, you'll see a 3 hour forecast model. And in red, I overlay the prediction interval, which is just basically the model error, which I then use as an indicator of a lower and an upper boundary. So the terminal operator can have an idea of worst case scenario, best case scenario, and what is the prediction. So the wind-bound event ended at about 10 a.m. on the 10th of December. But 3 hours prior to that, the measured wind speed was about 22 meters per second or 23 meters per second gust. The model predicts 3 hours in the future, the wind speed will be 15 meters per second. And on the right there, I just indicate that the actual measured was then 14 meters per second. So the model was about 1 meters per second out. So in summary, at a short-term range, the model is useful to predict wind speeds, or at an operational scale to 3 hours. So an operator can then use this as an indicator of when the wind speed is going to go out or go to the extreme range, and when it will return to safe operating levels. Okay, thanks.
Thank you, Vuyo. Thank you so much. The next talk is from Tukelo, which is considering temperatures in informal dwellings. Thank you, Tukelo.
Thank you. Good afternoon, everyone. My name is Charlene, and I'm a lecturer at the University of Johannesburg. Today, I'm going to be presenting a study, Tukelo's study. Tukelo is actually my ex-student. This study was done in collaboration with the South African Medical Research Council. In South Africa, as we all know, we currently have more than 1 million people that's still living in informal dwellings. Informal dwellings are also known as shacks, shanty towns, and slums. There's mounting evidence that cold temperature is associated with harmful health effects. The WHO recommends 18 degrees Celsius for indoor temperature to protect the population's health. Our study aimed to measure wintertime temperatures in informal dwellings in Bekkersdal, which is in the Randwest District municipality. The image you see on the slide basically gives you an idea of where this our study took place. We had loggers installed in the shacks for 14 days to measure temperature at 10-minute intervals. We also used data from the South African Weather Services that was closest to the actual monitoring station. A questionnaire was administered to 127 of the actual informal dwellers, and the questionnaire looked at demographic information and dwelling characteristics. Indoor temperatures ranged from 3 degrees to 33 degrees Celsius. We had a mean of 13 degrees Celsius and a median of 12 degrees Celsius. Our daily mean temperature was found to be below the WHO standards for 94% of the study duration. Indoor temperature increased as outdoor temperature increased, and this association was found to be statistically significant. The majority of the informal dwellings were made from corrugated iron sheeting and had no insulation, hence the strong correlation between the indoor and the outdoor temperatures. Temperatures regularly dropped from 10 degrees Celsius and frequently dropped to 15 degrees Celsius. As you can see in this diagram, that's our second figure, those are hourly temperature measurements that took place in the 11 dwellings. The red line indicates the WHO threshold for minimum indoor temperature of 18 degrees Celsius and the upper limit being 24 degrees Celsius. The last figure at the bottom, that's figure 3, shows us a correlation between our indoor temperature measured inside the 11 dwellings and the outdoor temperature measured at the actual community sites. So people living in shacks are vulnerable to adverse health effects associated with extreme cold, and guidance on how to create airtight shacks with insulation is recommended. However, this is just a temporary solution. In terms of long-term solution, our main goal is to basically replace these shacks with adequate formal and low-cost housing options. Thank you, guys.
Thank you, Charlene. Apologies for calling you Tukelo. Thank you. The last talk for today is from Ross Blamey, UCT, on the diversity of ENSO impacts over the Eastern Seaboard.
Thanks, Hector. I think it's fitting we end off with a ENSO talk, considering what's just happened this recent summer. My interest in ENSO starts off on growing up on the farms in the Natal Midlands, where decisions on the farming was based on the seasonal forecast. And 97, 98, there was a strong ENSO forecasted and predicted to be a very strong drought. It didn't happen. And my dad, being a farmer, wanted to know why. And I think that's where my interest sort of stepped in from this, is understanding how do we analyze ENSO, how do we break down its characteristics, and when the expected drought from an El Nino doesn't occur, why is that the case? So I love data visualizations. The figure on the left there is what you're looking at the correlation between SSTs in the Pacific and South African rainfall for DJF. It's a strong negative correlation. So basically El Nino, we have drought. La Nina, we have wetting conditions. But it's not the same for every single event. So the question then became why? And it decided using various metrics, which farmers typically use to try and understand, well, how do we break down each ENSO event to try and understand what makes them unique? And what we ended up with was these things called bubble plots. Okay, there's a lot of information on here, so I'm actually not going to go through it in 5 minutes, but basically what you're wanting to see is the first top panel there. That's El Nino years, that's neutral years, and that's La Nina years. And what we have here is 4 different metrics used to try and to unpack the El Nino. We have the number of dry spells on the x-axis. Actually, need to look. X-axis dry spells, y-axis is the number of rain days greater than 10 millimeters. The size of the bubbles is rainfall, and the color of the bubbles is the number of hot days. And we've broken this down as proof of concept for the eastern regions of Southern Africa, which are the red lines, sorry, the red polygons that you see in the top left-hand panel there. And what you're wanting to see is during an El Nino event, to have everything down this side, and La Nina to everything being the top side. And you can see some cases stand out where it doesn't happen. There's 1987, 88, 1997, and 98. And in this paper, what we go into is, well, what makes those features, well, what makes those years stand out? And it works out to be regional circulation features have a much stronger impact on our climate. And they dominate the ENSO signal. And that is why what you see with ENSO is El Nino is forecasted, it's got quite a strong skill in forecasting, La Nina not so. And that is because there are other features like Botswana High and Angola Low, which play a more dominant role during those years. So this is what this paper goes into. And what we're hoping to do is unpack this a bit more with future work looking at the different parameters with regards to rainfall and temperature, to sort of develop a severity index to try and say, all right, if an El Nino occurs, what makes it severe? Is it the number of rain days we have? Is it the number of hot days we have? We're trying to break away from just going, it's above average rainfall or below average rainfall. We're trying to give parameters to farmers that actually makes it usable for them. From the climate science, we always go, here's a standardized anomaly figure of above average, below average rainfall. And a lot of people just go, great, that didn't really happen, because they experienced one extreme rainfall event, and that made the entire summer season wet when it comes to the standard deviation. But when you break down to the number of rainfall events, it was actually extremely dry. So this is what we're trying to do, is trying to create indices or figures which just make it a little bit more understandable for non-climate scientists with regards to ENSO impacts over South Africa.
Thank you, Ross. Thank you so much. Interesting talk also on usable science, usable information. I'm going to open for questions. When you talk of usable information, it reminds me of Bruce's talk, who was also talking about robust information and communicating it and for decision making. I know Dawn is coming from the Climate Services unit. I was going to ask her to answer on whether the warnings, because ultimately here we are talking about warnings, weather and climate extremes. And in this country, it is the Weather Service that has the legal authority to issue warnings. And so if those warnings are not communicated effectively, then you may find that all the science behind the scenes is really not doing what's supposed to do. Because the question is the manner in which warnings are being communicated to the public, is it the most effective way in probability terms, or in those yellow warnings that we see on TV every day? How many people understand those warnings that we see on TV every day? And I think that's an important question to ask, but it may be unfair to ask to someone coming from Climate Services, but it is important to disseminate so that the science we are producing is usable, and the limitations of the science are understood by the user community. Otherwise, decisions are difficult to make. based on information that is not usable. All right, thank you. I saw two questions, Wendy and Guy.
Thanks, a really interesting session. Mine is regarding William's talk, and I guess more of a comment than a question. Earlier today, I was I'm Wendy Foden from South African National Parks, and I was in discussion with the Table Mountain National Park manager today, and she mentioned that this fire season there have been 211 wildfires in Table Mountain National Park, up from 190 last year. And I think what's interesting is so this year, I think a total of 7 houses were lost. And those fires burned right up to the urban edge in Cork Bay, Fishhook, St. James, in dozens of places, right to the urban edge. And it's remarkable that only 7 went. And at least 2 of those, the flames never reached the houses. It was just the goods inside the houses that ignited from the heat. So the question might be, why is there such a low rate of building loss in so many of these cases? And I guess it speaks to what you showed about the extreme fire events, but also to the way that things are being managed in terms of preventing firefighting teams. And I think you mentioned that there've been really concerted efforts. But I'd be interested to see that table of the number of dwellings lost and lives relative to the number of fire events. I think that ours would be quite low, and maybe it's the USA and Australia who want to come to us for help.
Thank you, Wendy. William, I'll give you a chance so you can think about it.
Yeah, I've got a question relating to weather services and the funding model of weather services. There's a lot of research around the world which shows that investment in weather services repays at a rate of about 6 to 1. So in South Africa, every rand you invest in weather services repays the country 6 rand. And if the weather service information is integrated and used by the community and integrated into the international system, that repayment can be 20 to 1. So why does our Treasury demand that weather services sell their data? Why do they demand this? Because the investment of fiscal investment into weather services will be of huge benefit to the country. Just unlock it. It just doesn't make sense to me. And I really think that our community should be making representations to Treasury to fund weather services without the need for them to be so-called sustainable. It's not the most optimal solution.
Thanks, Guy. 1 or 2 more questions specifically to William and to Dawn.
Thanks. So my question is for both Dawn and William. So one of the warnings that gets put out is around fire danger index. And so I've always taken it quite seriously, and I send information to our parks if I get a fire danger index for parks in the Cape. But if I get a fire danger warning for parks in the Karoo, I think, well, there's no fuel, so I ignore it. But William's talk suggests that maybe that's not a good idea. But I've never actually heard of a fire resulting from those. Is it because nobody has trees in their garden in the other provinces? Or, yeah, and then so the other thing would be, is there method to adapt our fire warning so that it incorporates fuel, and would that be sensible in light of what William's been saying or not?
I'll take 1 more and then we'll get some response.
Thank you. I'm not sure, I'm not familiar on how the system works here in South Africa. I guess that from the discussions in the morning about, for example, certain events like drought, they are slower. So it is not, let's say, kind of an immediate response, as example for floodings. And I wonder if in some areas here in South Africa or in other areas, particularly in sub-Saharan Africa, we know that they are prone to floodings, and some of them are flash floodings, and some of them, let's say, it's very difficult to send the information to the population as a warning. But we do have this type of warnings. Let's say it's not related to climate change, but we know they work. Like, for example, in countries where there is the alarm from tsunami or the alarm for earthquakes, that they can really prompt the population for something that it is also based on data services by the special organisms. So I just wonder if that could also be added into some events in climate change, really to warn the population about extreme heat, flooding, something like that. And in terms of the wildfires, even in Europe now, it is getting even worse. And as probably some of you know, 2022 in London, we hit 40 degrees, which is, we are not used to that. Even I'm from Mexico, so my tropical soul receives well the 40 degrees, but majority of population do not. And there were fires. And there were fires because there was not any kind of warning to the population, and especially because you assume that the logic is going to be, I mean, people are going to apply logic, but the reality is everybody wanted to go out and have a barbecue. And that really created a problem because there were fires, something that has not been seen before in London. So again, I just want to know, well, how can we really engage the different research that is going on here, Australia, United States, and now even Europe, Portugal, France, Italy, also prone to wildfires?
Thank you. William, was that with you?
Yeah, thanks. Well, I'll try and go through them quickly. I had to produce a table, put an entry into a table for the worst wildfire disaster in South Africa versus Australia, California, Mediterranean as part of a book. And the worst one at the time was 2000, 2005. It cost 40 million rand to, wow, you know, compared to billions of dollars in the US, and 8 houses were burnt down. That is the biggest, most damaging fire we could find. It was embarrassing that fires were so unimportant. And at that time, I think it's because of the way urban planning in Cape Town. It's all, the houses go to a certain contour and it's only for that contour down. So fires have to move downslope, which is hard to do. The more recent fires, nicer fires, are more like California. Houses are spread all over the place. So there's a strong human component. The Overberg fires, you go and look at Betty's Bay or Pringle Bay and you just think, you know, these guys are asking for trouble. So I think a lot of it's to do with the arrangement of houses. I admire Sand Parks and their firefighting. I think the guys are really good, and the getting helicopters to go very quickly has been effective. But it's clearly a ludicrous way of dealing with fire. Famous must burn. So to immediately put fires out all the time is not going to work in the long term. Fuel and fire danger indices. The trouble is that the fire danger index that's used is for grassland fires, and the famous fires don't burn in the same way. So there's a lot of confusion. People think that drought causes fires. Drought in the grassland areas produces no fuel, so there's no fires. The drought in woody fuels like famous should cause fires, but in fact, famous can burn every year because the summer drought is enough to burn. So we've used the Canadian fire weather system, which is far better for woody fuels like famous. The karoo does burn when the grasses get in, and it's extremely destructive. So if you have a karoo area that you're interested in and it's been invaded by grass, that is lethal, and it will burn out all the karoo. There's another one. What is it? Yeah. There's some excellent fire ecologists now in the UK and in Europe. Stefan Duer is very good. And I think the UK has been very interesting, the fires that have been happening. Sorry, interesting. Scientifically very interesting, but also terrifying. And Europe has been burning big time. Portugal has had huge fires, and where the fires, right, most concentrated in the eucalypt plantations. Well, come on, guys. Knock out those plantations. They're lethal. Why spread Australia around the world? It's a very dangerous thing to do. The Greece fires, the peculiar thing is that if you go back to the classical literature, there were no fires in Mediterranean Europe. They don't talk about fires in the classical studies. You know, my memory's failing me at this point, or the Bible for that matter. And I think the difference is that they had livestock, lots of goats and lots of cattle. So they removed the fuel. So there are interesting interactions there. And southern Spain burns now badly because there's been a lot of people leaving the country to go to cities. Morocco didn't burn until recently, and now they're also showing their depopulation. So it's a more complex story. But yeah, Europe is burning, and it's definitely a problem for now, for the next few decades.
Thank you. Most interesting insights. Thank you. Don?
Thank you. So the first question from Prof. Mitchley, I'll end with it. I'll start with the other two questions. So the question on fire danger index. So as SOURCE, we do issue fire danger warnings, but then the equation that we're currently using for the fire danger is it doesn't take into account vegetation, but we are working on it, and then we improving our model. So one of the things we can do is to improve the resolution of the models to cater for that. So we're working on that. And then with the issue of flash flood and other warnings. So we do issue warnings, but then we work closely with the National Disaster Management Center to tailor make and make sure that they are disseminated properly to the relevant people. So they will tailor make it to suit the different communities that they doing. So initially we'll issue the warnings, and then NDMC will take over into the rest. And the last question, why are we not funding the weather service? I think that's a relevant and a good question. Yeah. Hence I said we as climate service providers, we need to come together and ask the question why, or how can we do to, or what can we do to ensure that SOURCE is funded well. But luckily we have our mother department next to me. So I think I will pass on the question and he'll say,
that was opportunistic. The question, before I deal with the finance, the question on the issuing of warnings reflect on the value chain as well, because they can issue warning appropriately on time. The question then, what happens thereafter? You issue a warning and you realize that you don't even have a public space for people to can be moved out of the danger area. So there are a lot of factors, in my view, that really start to trigger how do we collaborate system-wide, you know, from government and many other stakeholders. A case in point where your public spaces are now invaded by sheikhs. your public spaces are no longer available to be your rallying point in case of emergency. So those are some of the cases that are coming. Prof, funding. Funding is a very interesting one, and I think there is work that has gone into that, looking at the funding model. And the very difficult and complex discussion that you take with Treasury, Treasury start to look at the entire funding to not only source as an organization, but funding to all other institutions that are contributing towards the generation of climate information and so forth, to say collectively how much of funding is going there and are we able to optimize it as a collective, and we're no longer looking at it from just a single institution perspective. And I think also the complexity of this discussion is you are having this discussion under the current financial fiscal constraint, where they are slashing every funding for government. It is, in my view, a very important, complex, and difficult conversation. Post the study that has been undertaken on the funding model, we initiated conversation with Treasury. Those are ongoing conversation to say what will be the best approach. Can we push for a business case from a public good point of view for the climate services? So there are a number of engagement that are ongoing as far as that is concerned. Don't do it as yet, Prof. I'm hopeful that in the future we might start seeing a movement on this, but it's a serious conversation that we are having with Treasury, even ourselves, on this issue. But she did not talk about the selling of data.
Thank you. My time is up. Thank you very much.
Thanks very much. Folks, that brings us to the end of our first day. I'm like too tired to say anything sensible. But I was reflecting on the variety of stuff that we've heard today. I think the nature of this meeting is defined by the fact that there's a really wide range of disciplines and interests in extreme events, you know, from the basic science, as we are wont to do, all the way through to the real applications, with everything in between. And I don't want to dismiss that, because I think that is the nature of the beast here, is it is a very complex thing to manage. And so we've heard, you know, stuff about fire, about floods, about droughts. We've heard about particular events, heat events. And I always make the distinction between the climatological conditions that lead to an extreme event and then the extreme event itself, or the disaster that results from the extreme weather. And so, again, there's a lot to unpack in all of this. And we did and have and will try to kind of compartmentalize our thinking. The plenary session drifted off brief very quickly, which means that tomorrow's two group work events will probably do the same. So the conversations will continue. So we might have to adapt the questions just to direct the thinking, albeit not necessarily a bad thing that there's a variety of conversations happening. I just don't want to exhaust the conversation too early. So really glad that people have stuck it out and that there's so much interest in all of this. And so tonight we're going to relax and recover from the initiation of this meeting. Tomorrow evening, we are continuing until we start to drink, those that drink, at the little cocktail reception that we're going to hold here for dinner. So tonight's a free evening, but tomorrow is a very full program, again, with a mixture of the flash talks and the and some what are they called, keynotes, as well as a couple of video presentations and remote talks. And we have those two group work sessions tomorrow. So I hope that it's been a stimulating day and a successful day for you all. And we hope that you will be here on time tomorrow with everyone else. And we're starting at 8:30 in the morning. If there are any other programmatic or content questions. Guy, anyone else in the team that's got anything to say? Anything from the floor? Going once? Done. Thanks very much. We'll see you tomorrow morning. Oh, and I just want to thank our AV team who are doing a superb job. Thanks very much.